Good evening, everyone. By popular demand, you wanted a probability session, so we've set one up for you. So I'm going to discuss probability in depth. I'm I'm going to try to make this topic lot more simpler. There's a lot of there's a lot of say prerequisites for this topic, which I will also touch upon in the beginning of the session before I kickstart the entire probability bit. Right. So let's start. All right. For you to take one on rate time, work and speed. Guys, there are sessions that are planned on those topics as well. The future sessions will include data sufficiency, permutations, combinations. You will have mixtures. You will have rates, right? The topic of rates, and you'll have a topic of say remainders as well. So I've touched upon some aspects. Keep subscribed to the channel. You'll get updates, regular updates on what the exact dates are and what topics are. So we made a note of the topics that people want. So okay, so I'm going to share my screen. Let me do that right away. Once I share it, please confirm whether you're able to see it. And we'll start. Okay, I'm going to look at your comments on my mobile. So I'll be switching between the PPT and the comments on the mobile. So just a couple of ground rules, guys. Just ensure that you hold off on your doubts until I finish explaining everything, because this topic there's a lot of different ways of solving a probability question. I also want you all to keep an open mind, because I'm going to teach you probability in a very different way than what you might have learned before, right? So keep an open mind. I'm not going to use things like combination formulae. I will try to avoid using a lot of formulae and work with it. So it's going to be a very different process. Take a step back, look at what I'm doing, understand it, and follow the process. Okay. If you want me to solve it in the process that you use, you can put your solution on the chat window, and I'm absolutely okay to discuss it towards the end of the session. Okay. So just quick confirmation. I'm assuming all of you all can see my screen. So let's start. I'm going to shift to a sketchbook as well. Yeah. So let's start without any further ado. So probability. Now, like I said, right, there are certain ground rules I need to set with this topic. There are certain prerequisites that are required. I'm going to cater to those first before I dive in fully into this topic. So the first thing you have to understand when you work with the topic of probability is what exactly is its definition. And from a mathematical standpoint, how would you apply those definitions on some examples, right? So probability is defined as the chance of something occurring or not occurring, or the likelihood of something occurring or not occurring, right? It's the chance or likelihood of something occurring or not occurring. And to calculate that chance, probability mathematically is defined as the number of favorable outcomes divided by the total number of outcomes. Probability basically is a fraction where the numerator is the favorable outcomes. The favorable outcomes is what the question asks you to solve, what outcomes you want out of the experiment that you're doing. And the denominator is always the total number of outcomes. The total number of outcomes is always the set of all possibilities. Every possibility, that would be your total outcomes. Out of that total outcomes, what are the outcomes you want, or what are the outcomes the question asks you to solve for, is what we refer to as the favorable outcomes. Some of you all would have learned it as sample set and so, or sample space and so on. I'm just using simple terms to work with. The idea is pretty much the same. Probability is a fraction where the numerator is the favorable outcomes and the denominator is the total outcomes. Now, if you look at it here, right, the favorable outcomes are always going to be a subset of the total outcomes. They are always going to be a part of the total outcomes. So the favorable outcomes can only be equal to the total outcomes, or they'll be lesser than the total outcomes. So the numerator can always be equal to the denominator here, or the numerator will be lesser than the denominator, because the favorable outcomes are always a subset of the total outcomes. And since the numerator of this fraction is always going to be equal or lesser than the denominator, the value of probability will always lie in between 0 and 1, inclusive of 0 and 1. Got it? For example, the simplest example we take is the tossing of a coin, right, or rolling of a die. So if I ask you, what is the probability of getting a head when you toss a single coin? So if I toss a single coin, my total outcomes would be head and tail. That is a total of 2 outcomes. And the favorable outcomes that the question is asking me to solve is the probability of a head. And that's one favorable outcome out of the 2. So the probability of getting a head would be half. And you would say that is 50%. Similarly, if I say what is the probability of getting an even number when you roll a die? Again, if I roll a die, I'm going to visualize in my mind. The total outcomes would be 1, 2, 3, 4, 5, or 6. A total of 6 outcomes. And I want the probability of the even number. So the even numbers would be 2, 4, 6. That would be 3 favorable outcomes divided by 6 total outcomes, which would be half as well. Similarly, if I ask you what is the probability of a prime, when I'm getting a prime number when you roll a single die, again, my favorable outcomes would be 6. And my total outcomes would be 6. And my favorable outcomes here would be 2, 3, and 5. That would be 3 again, which would be half. So the point I'm making here is the definition of probability is basically boiling down to a fraction, where the numerator is always the favorable outcomes, the denominator is always the total outcomes, and probability will always lie in between 0 and 1, inclusive of 0 and 1. Similarly, if I take another example, let's say we have 50 boys and 50 girls in a class, a total of 100 people. And I ask you, what is the probability of getting a boy? So now I would again respect my definition. It's the favorable outcomes divided by the total outcomes. So the total outcomes here would be 100. And my favorable outcomes would be 50. Yes? Some test takers write this as probability of getting a boy would be 1 by 50. Remember, guys, it's not about choosing one boy out of the 50 boys. Okay, this is not going to be right. Right? You have to respect the definition of probability. The definition of probability says that the numerator is always the favorable outcomes, the denominator is always the total outcomes, and you divide the two. Similarly, if I have a bag and there are 2 blue, 3 green, and 4 yellow balls in the bag, and I ask you what is the probability of getting a blue ball, then that would be this total of 9 balls in the bag. That's 9. And the favorable outcomes would be the 2. So remember, at every step, I'm respecting the definition of probability. It's the favorable outcomes on my numerator. It's the total outcomes on my denominator. Right? Don't write probability of a blue is 1 by 2. This is something that you should avoid doing. You have to stick to the definition of probability. So that's the first thing that I want to speak about. It's just a small introduction of what prerequisites you require before I dive into actual probability, right? So this is the first bit, the definition. Second, you will also need to know a little bit of Venn diagrams when you approach probability questions, because one specific type of probability requires you to represent the probability in terms of Venns, right? So I'm going to give you a quick, overview of what you need to keep in mind. I would definitely recommend you going through and doing your groundwork on Venn diagrams before you start the probability topic, right? But I'll quickly give you a summary of what I require in terms of Venns. So when you work with a Venn diagram, what is important for you to understand is you're representing quantities in the form of circles. For example, if I say this circle represents the people who've passed math, and the second circle represents people who've passed English, when you work with any Venn diagram, there are two things that you have to be very, very careful about. One, you have to understand what each of these regions the Venn diagram, each of the regions represent in the Venn diagram. So if I call this 1, I call this region 2, I call this region 3, and the outer region 4, it is important for you to understand what each of these regions represent. And second, it is also important for you to understand to focus on the reading of the question. What is my question asking me to solve? Based on what statement the question gives me, I'll have to link that statement to what portion of the Venns are they speaking about. So let's do a couple of things here. First, let's understand what each region of the Venn represents. And let's do the reverse, right? I will give you a statement and you have to understand the critical meaning of that statement, and you have to link it to what region or regions of the Venn does that statement represent. So let's do the easy bit first. What does region 1 represent? Region 1 represents the students who have passed only math, because 1 is a part of only the M circle and not the E circle. Region 2 represents students who have passed both math and English. It's the intersection between the two. Region 3 represents the students who have passed only English, because it's exclusive to the E circle. And 4 is what's outside the two circles, which would be people who have passed neither math nor English. So the easy bit is this, figuring out what each region represents. The harder bit, though, is the reverse, and this is where this topic becomes slightly tricky. In fact, statistics becomes a slightly tricky topic, because it deals with how you read, comprehend, and process information. So if I do the reverse, I give you a statement. I want you all to process the meaning of that statement and tell me which region or regions does that statement represent. So the first statement: what region or regions represent the students who have passed math? Can you all quickly type in the chat window? What region or regions represent the students who have passed math? One and two. Similarly, what region or region represents the students who have passed English? That would be 2 and 3. Again, I'm going to make the statements more and more complex. I want you all to critically analyze the meaning, and that is something I want you all to focus on in this topic. It is very, very imperative that you read and process information well, okay? Because that's also going to be the crux of my discussion when we go into question solving, right? Read the questions, comprehend the meaning. What region or regions represent the students who have passed exactly one subject? Quickly in the chat window, what region or regions represent the students who have passed exactly one subject? 1 and 3. Exactly one means only math, only English, right? So 1 and 3. What region or regions represent the students who've passed at least one subject? At least one subject. Don't rush through here. Process the meaning. What is the meaning of at least one? And then give me an answer. One, two, and three. What is the meaning of at least one? One or more. So people who have passed one subject, right? That would be one and three. That's exactly one subject. Or people who have passed more than one subject. That's two subjects here since I've been limited to two subjects. So one, two, and three. What region or regions represent the students who've passed at most one subject? For people who've just joined in, guys, I'm doing some groundwork that is required before we start, core probability. So bear with me for around 15 minutes, right? At most one subject. Guys, think about it. I want you all to focus on the meaning of what you read. At most one. What does that mean? Maximum one or lesser. So at most one can be one subject. People have passed exactly one subject, or lesser than one. That's zero subjects. So it would be one, three, and four. What region or regions represent the students? I'm going to give you two questions here, and I want you all to think through before you all type in the chat window. What region or regions represent the students who've passed math or English? And what region or regions represent the students who've passed either math or English? I'll give you a minute to process. I want you all to think through. I want you to also, take what I'm doing here as groundwork to what we're going to do later. It's very important for you to learn to process the meaning of certain statements. So, what is math or English? And either math or English. What region or regions represent that? Vivek, no, I'm just putting 1 plus 2 because that's what you would do. No, you would add them here. I'll tell you where to add, where to multiply later. When we go into probability, that there is a discussion on that. How do you use the word and or? For now, just hold off, right? Here in a Venn diagram, obviously, if I want people who've passed math, I would take the number of people who are in region 1 and add them with region 2, right? Because this entire circle includes 1 and 2. Great. So I see mixed responses for this. Let's see. Math or English. Guys, whenever you have an or scenario, right? In Venns, when you have an or scenario, actually, let me do it this side here itself. When you have an or scenario is always a union between the two quantities. Okay, an or scenario is actually a union between the two quantities. So if someone asks you what is M or E, math or English here, it would be the union between the two. That would be 1 plus 2 plus 3. Either math or English, if you go by the English meaning of that, either math or English means out of the two, you can only pass one. You cannot pass both, right? So either math or English means I should consider the regions that have only math, only English, but I have to discard the overlap. So either math or English would be 1 plus 3. You see how tricky it becomes. The reason I'm doing this is because if I dive in directly into probability, there is a portion of probability that requires you to look at things in terms of whens. You will not be able to work with things, right? So remember, the or scenario is always a union, right? And an either an or scenario is, if I draw it, would be these regions excluding the overlap. It is very important for you to understand the statement and link it to the regions that you have in your Venn diagram. Okay, so at least one means the entire portion of the circles. At most one it would be 1, 3, and 4. You would not include 2. So you need to visually connect the statement to what the question is asking you. All right. This is the second thing that I wanted you to hold on to. Right. The first is the definition of a probability, which says probability is a fraction where the numerator is favorable outcomes by total outcomes. Understand and respect that definition. The total outcomes is always the set of all possibilities. The favorable outcomes are what you want, what outcomes you want to occur, or what the question is asking you to solve for. The denominator is always the set of all possibilities, right? The sample size that you're considering. And second, how do you work with regions of a Venn diagram? Right? I've taken a two-set Venn. Very rarely you'll get a probability question with three-set Venn, but I'm not getting into a three-set Venn at this point. A two-set Venn should be more than enough, right? You have to learn to understand what regions the Venn represents, and you have to learn to process the meaning of statements and link it to the regions of the Venn. Got it? That's the second bit that I want you to hold on to. The third, I want you to know how to arrange alphabets in a word. Right? I want you all to know how to arrange alphabets in a word. Why? Because again, we'll be making use of this process. You'll understand why I'm doing all this when everything ties in together. So, quick recap. Some of you all might know this already. If I give you the word Delhi and I ask you, how many different 5-letter words can you form using letters of the word Delhi? Somebody asked me, what is neither M or E? So quickly, guys, obviously neither M or E would be what is outside, right? So neither M nor E would be what is outside. I already have written that in the regions, right? I wrote 4 as neither M or E, whoever's asking me that question, right? So guys, coming back to this, arranging alphabets in a word. If I give you the word Delhi and I ask you how many different 5-letter words can you form using letters of the word Delhi? I see some of you all have typed in 5 factorial. Yes. So the shorter way of working with this would be if I give you, let's say, a word like A and D, right? And I ask you to give me all the different arrangements of this word A and D. So if I list it out, it would be A and D, ADN, NAD, NDA, DNA, and DAN. This would be the 1, 2, 3, 4, 5, 6 words that I can get. They don't need to make sense, right? But it's similar to me counting the alphabets individually and writing down that factorial for it. Because 3 factorial, if you calculate, would be 6. And this gives me 6 here, right? Now, similarly, when I have the word Delhi, all I have to do is I have to count the alphabets individually and write down that factorial, 5 factorial. The tricky aspect is when you have alphabets that repeat, right? For example, if I take a smaller example here, let's say A, A, D, right? And I ask you how many different 3-letter words can you form using letters of the word AAD? So what would I do? I would say AAD, let's list it out, ADA, and DAA. Anything else I list out would be repetitions of what I already have set up, right? So my answer should be 3 here. So how do we work with alphabets being repeated? We count the alphabets individually. We write down that factorial. But by writing down that factorial, we've considered all the different arrangements of A, and D among themselves. And obviously the arrangements of A among themselves gives me back the same word that I've already counted. I can't count a word twice. So what do we do to remove those extra counts? We divide by the repeating letter factorials. Right? Simple. You count the alphabets individually, you write down that factorial, you divide that by the repeating letter factorials. You need to remove the repeats. So if I give you, let's say, my name, Aditya, and I ask you, how many different 6-letter words can you form using letters of the word Aditya, where you can use each alphabet once, right? And you cannot repeat, each alphabet more than once. Okay, I'll put that condition as well, since some of you are asking it here. So, how many different six-letter words can you form using letters of the word Aditya? So again, I would count the alphabets individually. I would write down that factorial. But here I have the A's that are repeating, right? So I'm going to divide by the repeating letter factorials. Got it? Similarly, a very popular example. If I take the word Mississippi and I ask you how many different 11 letter words can you form using letters of the word Mississippi and using all the alphabets once only, right? So I would count out all the alphabets individually, write down that factorial, that's 11 factorial. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then divide by the repeating letter factorials. That would be 4 factorial for the 4 S's, 4 factorial for the 4 I's, and 2 factorial for the 2 P's, right? So remember, when you're arranging alphabets, I'm just giving you a quick overview. I'm not going to get in depth into this and what are the properties. We will do that in our separate session of permutations and combinations. But this is something that is a prerequisite before we dive into probability. How do you arrange alphabets in a word? So you count the alphabets individually, you write down that factorial, you divide by the repeating letter factorials. Got it? Yes? Any doubts on this before we move ahead? Yes, I think the background noise is gone now, so sorry for that. All right. Okay. The fourth, and I would say this is like the most important aspect of this topic, and this is where normally many test takers struggle, right? Is visualization. How do you visualize a question, and how do you bring in common sense in terms of working rather than approach a question from a mathematical standpoint, right? So I'm going to speak about visualization for a bit, because that is also something that we're going to focus on when we start probability. When they say n letter words from m letters is without replacement default, no, it will be mentioned, redacted. Okay, so they will mention it, how the alphabets are used and how digits are used. The question will always give you some information on whether it can be repeated or not. Okay, so it will be mentioned in a question. With people, by default, nobody's going to mention that, right? I mean, if you're forming a group of 3 people, if you pick one, you're not going to put that person back. Correct? All right, guys, like I said, I'm not going to go in depth in arrangements and selections. It is for another session. I need that fundamental understanding before we go into what probability is. Now, coming back to visualization. Visualization is something that is super, super important. Okay. And you'll see me touching upon this as we go forward in the solving of our questions. So I'm going to give you a snippet of a official GMAT question. I don't want you to solve it and give me an answer. Okay. I want you to work with me in how you would visualize the question. Okay. If you get an answer to it, it's absolutely fantastic. But I want you to work with me on how to visualize it. Okay. Um, let's say we have 5 married couples, and you need to form a team of 3 members such that a couple is always a part of the team. Any couple. I don't want you all to give me an answer. Okay. I don't want you all to give me an answer. The purpose of me giving you this scenario is for me to show you how you would visualize. Right? Okay. Uh, Shreyansh, will come to that, right? Just guys, like I said, hold off on going directly into it. I will deal with replacement, without replacement, when I get into core probability. At this point, what I'm telling you here are the groundwork that is required before we go ahead. Okay, I need you all to know this and look at questions this way before we dive into probability and the concepts. Okay, so just hold off. I will touch upon everything at the end of the discussion. If you have any doubts, let me know. Okay, so I'm giving you five married couples, and I'm telling you to form a team of three members such that any couple is always a part of that team. Now, I don't want you to solve it and give me an answer. I think for those of you all who know how to work with permutations, combinations, will be able to do this. But what I'm focusing here is I'm going to use this example to show you how I would visualize. And what do I mean by saying that visualization and common sense are like very important aspects of working with probability, permutations, and combinations, right? So when I see information like this, I have five married couples. I put myself in that question, right? When I visualize, I always visualize from a first person's perspective. I put myself in that question and I say, okay, I'm standing in a room. I have five married couples in front of me. Let me tag them like this: M1 F1, M2 F2, M3 F3, M4 F4. This is what I call the visual component of your question. This will be very, very crucial towards how you break down the question logically and how you set up your math. So, what I'm teaching you here is how to develop a visual component, how to bring in visualization and common sense while working. So, I have five married couples. I'm standing in a room. I'll draw that stickman figure, however funny it looks, right? I will draw it because it tells me that I'm here and I have these five married couples standing in front of me. And somebody comes and tells me, this is how I would ask myself and bring in common sense. Somebody comes and tells me, Aditya, I want you to select a team of three members such that a couple is always a part of my team. Now, I want all of you all to put yourself in that scenario. You're standing in a room, you have five married couples in front of you. Someone comes and tells you, I want you to make a team of three such that a couple is always a part of your team. Now, bring in common sense here. What would be the first thing that you would do? That's the question. If someone comes and tells you, you need to form a team of three such that a couple should always be a part of your team, and you see five married couples in front of you, what is the first thing that you would do? Think about it from a common sense point of view. Put yourself in that scenario and try to answer the question. What is the first thing that you would do? You would always first pick a couple. Anybody would do that, right? Because the condition is I want a couple to be a part of my team. So I would first pick a couple. And when I pick a couple, it would cater to two positions of my team. Right? For those of you all who want to know what it is, so if I write it in terms of a combination, it would be out of the five couples, I choose one. For those of you all who don't know what combinations are, forget I said it. So what you're doing, you're going to select one couple out of the five. And then once you've selected a couple, let's say M1, F1, this is our couple that we've selected. From the remaining couples, I can select any one person, right? So the remaining is 1, 2, 3, 4, 5, 6. I can choose any one person out of the remaining. So this is what I want you to do. I want you to visualize a question exactly the same way as what you would do in a real life scenario if that scenario was presented to you. Represent the objects with alphabets. Imagine that you're in a room with those people in front of you, and this was the condition given to you. Correct? Any doubts on this? I'm not getting into how to solve it, guys. This is not required at this point. The point I want to, bring forward here is how you need to visualize. When I say visualize, when I say bring in common sense, it is exactly how you would react in a real life scenario if somebody presented this to you, right? And you're standing in a room with 5 married couples. Got it? Any doubts on this? Consider a couple with one entity. Guys, I don't want you to look at it mathematically. Just think about it from a common sense visual standpoint. Forget the math. If I was standing in a room, I had these 5 couples in front of me, I had to select a couple had to always be a part of my team. How would I make my selection? Pratik, I told you I'm not getting into permutations and combinations at this point. It's obviously I'm making a selection, so it's a combination. It's not a permutation. So that should answer your question. But I'm not getting into solving at this point. Okay. Now, let's take another example. Okay. And I want you all to try to visualize. Do not worry about solving. Okay. Forget about solving, forget about permutations, forget about combinations. Just focus on visualizing the question from a logical standpoint. Draw the visual representation, put that stickman figure, and ask yourself, if this condition was given to me and I had to select objects from some objects or place objects in some spaces, what would I do? Right? So I'm going to give you a family. Again, this is an official GMAT question. I'm just taking a snippet out of it. So I'm going to give you a family, and that family consists of 5 members. Okay. A father, a mother, a son, and 2 daughters. And they're going on a road trip. Okay. And they are driving a car. And that car has 2 front seats and 3 back seats. Now, the question is, in how many ways can I arrange these people such that a parent has to drive? Again, I don't want the answers. I just want you to visualize. A parent has to drive. And the are daughters do not sit next to each other. Guys, I don't want the answer. I don't want you to worry about what numbers go where. I just want you to visualize, right? So how would I do this? I have a father, I have a mother, I have a son, 2 daughters. And there are 2 front seats, 3 back seats. And I'm standing here, right? I'm visualizing myself there as a stickman figure, right? Doesn't matter, guys. Right hand drive, left hand drive, doesn't matter, right? Just it's okay. If you're using a left hand drive, just put the 2 spaces onto the left instead of the right. Okay. Now, say this is the driver's seat. Okay, for those of you all getting confused, right? This is the driver's seat. Now, again, I'm not asking you to solve. I'm asking you to visualize. Imagine this: that I have 5 people in front of me. I have a car, and the doors of the car are open. And I have 2 front seats and I have 3 back seats. And someone comes and tells me, Aditya, I want you to arrange these people in such a way that a parent has to drive and the daughters should not sit next to each other. So, in my mind, what would I do? I'm going to visualize this. I'm not going to put numbers and try to solve. I'm going to visualize. How can I place these people such that these conditions are satisfied? So I need a parent to drive. So I know a father or the mother can occupy that space. That's logical. And the daughters should not sit next to each other. So the question I'm going to ask myself is, if I was in that scenario and I have these 5 people in front of me and I have to place these daughters onto seats such that they are not going to sit next to each other, where all would I place them? I would place them here, because if one daughter sits here, one daughter sits here, they are not going to be together. Or I can place them here. One daughter sits on the front seat, one in the middle of the back seat. I can place them here. One daughter in the front, one daughter in the bottom right, or I can place them on the extremes. This is what I want you to do. I want you to visualize it like a real life common sense question. The question you need to ask yourself is, if I have to place the daughters onto these five seats and they should not sit next to each other, where all would I place them? Think about it. It's not a difficult question to answer. It is exactly how you would view a car with five seats and somebody giving you those two daughters and asking you to place the two daughters such that they are not together. So I can place them on these two, these two, these two, and the corner two. So there are four scenarios. There are four cases that I can place the daughters. Got it? Again, I'm not going to solve this question. The purpose is how to visualize. This is my visual component. You see, what am I doing? For any question, I am attacking the question not from a mathematical standpoint, I am attacking a question from a visual standpoint. Both here as well as here, I looked at that question visually. And this is what I want you to carry forward when we go into probability as well. The visualization of a question. Got it? I want you to visualize a question exactly the same way as how you would work with in a real life scenario if that real life scenario was presented to you, right? Put yourself in that question, make it a first person's perspective. It becomes easier for you to work. Okay, I'm not going to solve this. Don't ask me how to solve. It's not at this point. I'm not going to cater to that. We will deal with all of this in the permutations, combinations bit. The focus is on the visual aspect, on the visual component of what I did to break down the question. Got it? Now, let's dive into probability. Okay? Now, like I said, I'm going to give you a very different perspective of probability, the way I have learned this topic. So it may be very different from how you looked at it. But like I said, keep an open mind, understand what I'm trying to say. Whenever I see a probability question, right? All probability questions, I try to classify all probability questions into one of three types. The first is what I refer to as a single event. What is a single event? A single event is when you're working with one object or you're selecting one object from a group. For example, I'm tossing one coin, I'm rolling one die, I'm picking one card from a deck of cards, I'm picking one ball from the bag of balls, I'm picking one person from a group. So whenever you're working with only one object, or I'm selecting one object from a group, that event is what I would always classify as a single event. The second is a complex event. It's also referred to as an AND probability. When I'm working with more than one object, for example, I'm tossing one coin two times, or I'm tossing two coins at once. Both of them are the same. They are independent events. I'm tossing one coin two times or two coins at once. I'm rolling two dice simultaneously. I'm picking three cards from a deck of cards. I'm picking three balls from the bag of balls. We'll look at how to pick later. I'm picking three people from a group. So whenever I work with more than one object, or I'm selecting more than one object from a group, then that event is what I would classify as a complex event. And why am I saying it's an AND probability? Because think about it, right? If I'm tossing a coin twice, If I want to find a probability, it would say, what is the probability of getting a head and a tail? If I'm picking two balls from the bag of balls, whether it's one by one with replacement or without replacement or simultaneous, we'll deal with that later. If I'm picking two balls from the bag of balls, let's say a blue and a green, it's always going to be a blue and a green. If I'm picking three cards from a deck of cards, it would be a king, another king, and a king, and a queen. So whenever you have complex events, you have an and condition that runs, right? If I'm picking Aditya and Abhijit, right? It's an and condition that runs. So complex events are always and probabilities. And third are the or probabilities. Whenever you see a question that asks you, what is the probability of something A or B? What is the probability of neither A nor B? Variations of the word or. What is the probability of either A or B? Whenever you have or used, you have to approach it as an or probability question. And or probabilities are the ones where we make use of Venn diagrams. So any probability question, what I do, what I've taught, what I've been taught is you read the question and you classify it into one of these three types: a single event, a complex event, and an or probability. What is a single event? How do I do that? A single event is when I'm always picking one object from a group at a time. I can have multiple groups, but I'm always going to pick one object from that group. A complex event is I have one group, but from that one group, I'm picking multiple things. I have one bag. That bag has blue, green, and yellow marbles. I'm picking one blue and one green from that bag. So remember the difference between a single and a complex. A single event is when you're always picking one object from a group. You can have multiple groups, but at every time from those groups, you're picking only one object. So I can have two bags. Here I can have two blue, three green. Here I can have three blue, two yellow. And I can ask you, what is the probability of getting a blue from bag A and a yellow from bag B? You see, this is what I would say is a single event. I'm always picking one from a group. But if they tell me that I have a bag, there are two blue and three green, what is the probability of getting a blue and a green? When you pick two balls from the bag A, that would be a complex event for me because this would be a blue and a green. Make sense? Here also, you will have an and condition running because if I want to ask you what is the probability of getting a blue and a yellow, right? I would write it like this, but you see how I'm writing it. I'm writing it as two separate alphabets, right? This is from bag A, this is from bag B, this is from one bag itself. So the difference between a single event and a complex event is in a single event, you're picking one object from a group. You can have multiple groups, but you're always picking one. In a complex event, you're always picking more than one from a group. There also you can have multiple groups, but you're always going to pick more than one from each of the groups. And when you have an or probability, if the question asks you, what is the probability of Manchester United winning or Arsenal winning? What is the probability of neither Manchester United winning nor Arsenal winning? What is the probability of either Aditya winning or Abhijit winning, right? When I give you things like that, when you have or variations of or, I would always think of or probability. So that's the first thing I want you to do. I want you to try to classify the question into one of these three types. What we will do, we will look at each one of them one by one, right? You look at each one of them one by one. I'll start with the single events. I will go into or probabilities, and then I will end with complex probabilities. Okay, complex events. So far, any doubts? Any doubts, guys? We're getting into now core probability concepts. So any doubts, ensure you get it clarified now. Don't ask me about arrangements and things now at this point, because we're not going to deal with arrangements and combinations with questions. We're going to deal with probability. We're going to just focus on probability. There's another thing that I wanted to put across here, and somebody I think also mentioned it before. Guys, whenever you work with this topic, right, it's important for you to read a question and understand whether there's an or condition that is running or an and condition that's running. A simple rule of thumb is whenever you have an and condition that's running, it is always a multiplication between the quantities. Aditya and Abhijit, blue and green, I would multiply them. Probability of blue and probability of yellow, so I would multiply. But if you give me an or condition that runs, an or condition always means addition. Okay, I want you to keep this as a rule of thumb while working with questions in probability and permutations and combinations as well. And always means multiplication, or always means addition. Okay. All right, since all of you all are okay with what we've done so far, let's go into a single events. A single event is like core probability. It's like the basic understanding of what a probability question is, right? Like I said, when you work with a single event, you're always working with one object. You're tossing one coin, you're rolling one die, you're picking one card from a deck of cards, one person from a group, or you're selecting one object from a group. And since this is pure probability, if you need to calculate the probability of any single event, it boils down to its fundamental definition. In any single event, your focus has to just be on using the definition of probability. It is the number of favorable outcomes on the numerator divided by the total number of outcomes on the denominator. Right? That's why I said these are like low-hanging fruit. They are slightly more easier questions, but they can be complicated if they are combined with other topics, and we'll see how they are combined as well. But if you see that you're picking one object or you're working with only one object, then everything boils down to the simple definition of probability: favorable outcomes by total outcomes. But what is important for you to understand here is this. These are some guidelines that you have to keep in mind while working with single events. It is very important for you to read, visualize the question, and comprehend what the question is asking. Very, very crucial. Read, visualize, and comprehend the entire scenario that is being presented to you. After you do that, list out all the total outcomes. It is very important for you to be patient on these kinds of questions. If it's a single event probability, I have to learn to list out the total outcomes. If the numbers are small, obviously I can list them out well. But if the numbers are larger, then what do I do? If the numbers are larger, I would make use of patterns to figure out what the total outcomes would be, some sort of pattern. I don't have to sit and list out everything. Is there something that I can see, some pattern that I can see to get the total outcomes very quickly? So I would first list out all the total outcomes. Then I would figure out the numerator, right? The total outcomes, remember, is your denominator. Figure out the numerator, that's the favorable outcomes. I would list them out and list out the outcomes. And then divide the two. You have to learn to do this, right? There are two kinds of questions that you're going to get when you're dealing with single events. I told you these are like low-hanging fruit on this topic, but the first kind of question you're going to get are standalone questions. Standalone questions means they are pure probability questions. They are probability questions, and They will require you to break the question down, list out the possibilities, and divide the favorable and the total to get to an answer. But also, what happens with single events? Normally, single events are always combined with other topics as well. They'll give you a Venn diagram question and they'll throw in the probability aspect towards the end. What is the probability of getting a person who drinks both coffee and tea? Right? Or in a number property question, what is the probability of getting a sum that is even? So they'll always combine it with other topics. At the core of it, you will need to work with Venn diagrams well. You'll need to work with number properties well. But what they're doing is they're throwing in the probability aspect towards the end. So all you have to do is you have to figure out the favorable outcomes. You have to figure out the total outcomes and divide the two. Let's take an example, okay? Let's take a couple of examples of standalone questions. Let's look at it combined with other topics as well. The way I'm going to look at things is from a very logical perspective. So I'm not going to jump into the math very quickly. And I want you all to also try to do that, okay? Because I told you, what is most important for you to understand in these topics is you have to focus on reading, comprehending, visualizing, and setting up logic. If you don't do these three things, it is very difficult for you to set the math down. And that's why most test takers struggle with this topic, because they don't look at these three aspects before diving into the math. So let's take a question. Let's say I have a set A, and that set A has 4 elements, 1, 2, 3, 4. And I have another set B, and that set B has elements 5, 6, 7, 8, 9. Let's say 5 elements. And I ask you, what is the probability of getting a sum greater than 10 when you pick one element from set A and one from set B? Now, I want you all to see how I'm going to approach this. For people who want to give it a shot as well. But this is how I would approach such a question. Okay. The first thing I would do, I would read the question. I would try to understand what the question's asking me. I've been given two sets. They're asking me the probability of getting a sum that is greater than 10, not equal to. When you pick one element from A and one from B. So the question is asking me, it's giving me two groups, A and B. It's asking me to pick one from each. And it's asking me to check whether the sum of those numbers that I've picked is greater than 10 or not. So I'm picking one element from a group. And as soon as I see that I'm only picking one element from a group, I know it has to be a single event. My focus has to be now on figuring out what my total outcomes will be. I will always try to do the total outcomes first and then figure out what my favorable outcomes are. Figure out the numerator, figure out the denominator. Always try to figure out the total outcomes. Now, what will be the total outcomes? Don't give it to me from a mathematical standpoint. Understand how you get the total outcomes. Remember, you're picking one element from A and one element from B. And you're checking whether the sum of those two numbers is greater than 10. So if I'm picking one element from A and one element from B, what would be my total outcomes? The total outcomes will be all the different combinations of numbers from set A and set B. I mean, I'm not going to write everything down, but let's say it's 1, 5, 1, 6, 1, 7, 1, 8, 1, 9. Similarly, 2, 5, 2, 6, 2, 7, 2, 8, 2, 9. 3, 5, 3, 6, 3, 7, 3, 8, 3, 9, 4, 5, 4, 6, 4, 7, 4, 8, 4, 9. I don't want to list it out like this. Like I said, look at patterns, try to understand it. So with one, there are 1, 2, 3, 4, 5 possibilities. With 2 also, there's going to be 5. With 3 also, there's going to be 5. With 4 also, there's going to be 5. So 5 plus 5 plus 5 plus 5 would be 5 times 4, which is 20. So the total outcomes would always be 5 times 4. And this is where, let me put it this way, 4 times 5. It's the same. Since I've written the set A first. So this is where you have to understand that the total outcomes that you get will always be the product of the individual outcomes. There are 4 possibilities for A and there are 5 possibilities for B. So there should be a total of 20 possibilities. And the 20 possibilities would be 1, 5, 1, 6, 1, 7, 1, 8, 1, 9 till 4, 5, 4, 6, 4, 7, 4, 8, 4, 9. Right? So the total outcomes here would be 20. I've got to that. I've got to my denominator. Now I need to figure out my numerator. What is my numerator? The favorable outcomes are I need the outcomes that give me a sum greater than 10. So with 1, there is no combination that gives me a sum greater than 10. So with 2, there's only 1, 2, 9. I'm going to list it out. With 3, there's 3 8s, there's 3 9. And with 4, it would be 4 7, 4 8, and 4 9. So 1, 2, 3, 4, 5, 6. There are 6 favorable outcomes. So my probability here would be 6 by 20, which is 3 by 10. Correct? I want you to understand this. I don't want you to look at it mathematically. You see, I didn't directly go into 4 into 5. Some test takers would use 4 plus 5. Now you understand why it's not 4 plus 5. What are you doing? You're trying to find out your total outcome. So I'm looking at it logically. If I need the total outcomes, I need all the different combinations of elements from set A and set B. Right? So 1, 5, 1, 6, 1, 7, 1, 8, 1. With 1, there are 5 possibilities. With 2, there are 5. 3, there are 5. 4, there are 5. So 5, though those 4 numbers can combine with any of those 5. So 4 times 5 would give me 20. And I want you to learn from this that the total outcomes will always be the product of the individual outcomes. Correct? And then what did I do? I listed out my favorable outcomes, got to an answer. So what is important for you to work with when you're dealing with a single event? It is important for you to process the meaning of a question. Read, visualize, comprehend the meaning. When I say visualize, draw it out. Right? In this case, I did not have to draw anything, but draw out the entire scenario. Understand what the question is giving you. Comprehend it. Then ask yourself, am I dealing with a single event, complex event, or an OR probability? How do you figure that out? When you're picking one object from a group, a single event. When you're picking more than one, a complex event. When you have an OR scenario that is being asked for you to solve, and Venn diagram approach. Since we're only dealing with single events, here it is a single event here because I'm dealing with picking one element from a group. I know a probability of a single event boils down to its baseline definition. I figured out my favorable outcomes, figured out my total outcomes, divided the two. Got it? Tushit, I'm not giving you multiple. I'm not giving you the fastest way to work. If I was working with this on test day, I would just do 4 into 5, 20. Right? I wouldn't list out 1, 5, 1, 6, 1, 7, 1, 8, 1, 9 till 4, 9. I would just write 4 into 5 is 20 is my favorable outcomes. And I would list out the possibilities that give me a sum that is greater than 10. I cannot otherwise work with the numerator. Other than listing it out, I will not be able to work with that numerator efficiently. Understood? It's not about the time. It's about how I'm focusing on how you learn. Obviously, I'm not going to write this, guys, on test day. I'm writing it here for you to understand. Some of you all would have written 4 plus 5, 9. So for those of you written 4 plus 5, 9, you understand why you need to use a multiplication. All right. If I was doing this question on test day, I would directly write the total outcomes as 4 into 5 because it's combinations that I want. And then I would only list out these possibilities. I can't find out what combinations add up to, some value greater than 10 without listing it out. Got it? Yes? Any doubts? Okay, let's actually pick an official question then. To start with, I'm shifting to my PPT. Let's give a shot at question 1. What if the numerator is not countable, Vivek? If the numerator is not countable, then you can sue GMAT for giving you a question like that. Obviously, think about it from a test maker's perspective. No, they're not going to give you a numerator which is not countable and ask you to solve, right? The question is going to be designed in a way that you can logically work with it in a 2 minute time frame. Right? Nobody is going to ask you to list out 110 possibilities. If if they give you a question where 110 possibilities are there on the numerator, then obviously there should be some sort of pattern that applies to work. Okay, I'm going to give all of you all a couple of minutes on this question. Remember, guys, guidelines: read, visualize, comprehend, break the question down, figure out numerator, denominator, divide the two. So Vivek, if the numerator is not countable, it's a very large value. There always will be a logical way to count it out. So you have to figure that out, right? Nobody's for every numerator. I can't create a formula. You'll have a question coming further that will answer that for you, right? So if you get a large numerator, how do you figure that out? Okay, you can start typing your answers in the chat window, please. I think there are 70 and odd people logged in, so I would expect all of you all to give me an answer at least. It doesn't matter whether it's right or wrong. And also, please, let the YouTube algorithm do its work. Like the video if you've liked things so far, right? Please ensure that you put in the answers in the chat window. Doesn't matter whether it's right or wrong. Okay, and you'll understand why when we work with this question, why I was very particular about visualizing the question, reading, comprehending, and working, because it is those skill sets and not knowing formulae, right, that is going to hold you in good stead in these topics. So most of you all have said, okay, it's a toss up between E and D. I've got also an A. I can understand why A as well, right? Remember, Ria, read the question carefully. The last bit, last two words should be read very carefully, right? Last call for answers before we discuss. Guys, don't be afraid to put in your answer. Okay, the point I'm trying to make, I've taken a simple official GMAT question, right? And the reason I've taken this question is to reinforce the point that it is not about knowing formulae in this topic, right? The skill sets that you need to develop are visual logical skill sets, reading skill sets, and then integrated with a math towards the end. Okay. All right. I see Ria has changed her answer. Okay. All right. So let's discuss this, right? So I think it's a toss up between D and E. And this is where, making the question as real life in nature as possible would help you out. Okay. So the first thing is, I cannot skimp on the reading of a question. I have to read it slowly. I have to comprehend the question. This is what most test takers don't do. It's a very weird advice I'm giving you here, but you'll understand this as you go forward in your prep. To get faster on questions, it's always best to slow down in the beginning. Because when you slow down in the beginning and you read a question carefully and process the information, your understanding of the question is really good and you will make the right decisions towards solving. If you rush through, more often than not, you'll miss out on certain nuances. All right. The seating chart of an airplane shows 30 rows of seats. Okay. Each row has three seats on each side of the center aisle. I'm going to stop you. I want you to observe as well how I'm reading and breaking down the question as well. So each row has three seats on either side of a center aisle. So I'm visualizing myself traveling in, let's say, a Vistara plane, right? It's exactly how the inside of a plane would be. So this is the center aisle. I have three seats on either side of the center aisle, and I have a total of 30 rows. So you see, I would write this, I would visualize this in the question, right? So how many seats would I have in total? Each row would have six seats. So the total seats would be 30 into 6, which would be 180. I'm done the first part. I visualize my first bit, right? Now, the view from the window seats in five of the rows. So let's say, these were the five rows, right? The view of the from the window seats in five of the rows is obscured by the wings of the plane, right? The view from the window seats in five of the rows is obscured by the wings of the plane. So, if I have five rows and the view is obscured by the wings of the plane, how many seats have obscured views? How many seats have obscured views? Anyone? Can you quickly type in the chat window? Guys, interact. How many seats have obscured? 10. The view from the window seats in five of the rows is obscured by the wings of the plane. If the person, so that how many are obscured? 10 are obscured. And how many are unobscured? That would be 60. Would that be correct? Is 10 obscured or 50? What do you think? The statement says perfect. Okay. And how many would be unobscured? Perfect. Now, the question says, if the first person, so imagine I go to the Vistara counter. I am the first person there. If the first person, if the first person to be assigned a seat is assigned a window seat. Now I go to the Vistara counter and I'm the first person in that line. The person opens up, whatever the laptop there, and he's going to assign a seat to me. and the software tells that the first person to be assigned a seat is a window seat. So in that laptop, only the window seats are going to open up. So if only the window seats are going to open up, what would be the total outcomes for that person to be assigned a seat? It would be all the window seats. And what would be all the window seats? It would be 60. So think about it, right? I'm the Vistara employee. I'm the person who's giving the ticket to the Vistara employee. He opens up his laptop. The first person is always assigned a window seat. So only the window seats open up for assigning the seat to me. So the total outcomes here would be 60. And the question is asking me, what is the probability that the person will get a seat with an unobscured view? So if 10 seats are obscured by the wings of the plane, the remaining 50 seats would be unobscured. That would be 5 by 6. That would be my answer. So the people who gave me E 17 by 18, you all did the diagram well. But when you read the second part, you all missed out on this part. If the first person to be assigned a seat is assigned a window seat, so what is your sample space? What is the total outcomes you're dealing with? All the window seats. And I want the probability of getting an unobscured view, right? So that would be 50 by 60. That's 5 by 6. That's my answer. So you see, it's not about the math here. That's the point I want to make with this first question. It is not about the math. It's about how you visualize. And someone asked me, would I count it out? No, I definitely would not count it out. You see, I just used simple common sense math to say that's 30 into 6. That's 5 rows into 6 would that would be, I mean, the total number of rows into how many are obscured, that would give me the total seats that I have to consider. Then finally the obscured would be 10, unobscured would be 50. I did not at any point try to sit and count everything out, right? I drew it out and then I looked at a logical way about working. See, 60, for those of you who are not getting what is 60, read the last part, guys. If the first person to be assigned a seat is assigned a window seat, so how many window seats are there? The window seats are going to be 60, right? The view from the window seats in 5 of the rows is obscured by the wings of the airplane, right? Make sense? So each 5 rows are what we call the window seats, right? And each of the rows has 6 seats. So 5, think about it. Well, how do you get that 60? Got it? So whenever you have a question like this, learn to visualize the entire question. It becomes easier for you to work. Yes. So think about it, guys, right? You have all 30 rows. For those of you who are wondering how I got the 60, for there are 30 rows. Now these would all be the window seats, right? I don't have to tag it, but these would all be the window seats. So the window seats, there are 2 window seats per row and there are 30 rows. So there are totally 60 window seats, right? And out of those window seats, they're telling me 5 of the rows are obscured by wings, the plane, right? So that's obscured would be 10, unobscured would be 60. Got it? So again, going back to what I said, it is very important for you not to focus on the math. It is important for you to focus on reading, visualizing, and the logical setup of a question before you get into the math. Okay, if these 3 go right, your math will always be right. All right. Okay, let's try one more. Give it a shot. Again, I'm repeating, read, visualize, put yourself in that scenario, set up your visual component on your sheet, then start working. Do not dive into the math directly. Okay, you can start typing in answers. Again, most of you all will take some time to understand, the visual process, because it's a very, difficult change that you all will need to make. Normally, you all have been taught to approach questions from a very mathematical standpoint, and I see that with the answers here, right? Guys, I mean, this is not a very difficult question. It's just that, see, the also I would say the percentiles and probability questions are a little skewed, right? Because half the test takers don't, invest time on this topic, so they let the question go. So the percentiles are very skewed. So any probability question, will ideally be, medium or a high difficult level question. That does not mean you only get those. You would still get easy, medium, and hard. I would classify this as an, in between an easy and a medium question. Okay, it's not too difficult, right? The problem is that you approach the question very mathematically rather than breaking it down and visualizing. And that's what I'm trying to make you all do, right? Slow down on your process, try to understand it, put yourself in that question, visualize it like a real life scenario. Because if you do that, the question just boils down to very simple calculations. So I see it's a toss up again between A, C, and some of you all have given me D as well, right? So let's look at this, right? Let's understand the question and let's break it down. You see, I'm not approaching it from a mathematical standpoint first. I'm going to look at it, I'm going to read it, I'm going to visualize what I'm reading. A certain junior class has 1,000 students. So I have a junior class, there are 1,000 students. So in my mind, J1, J2, J3 till J1000. And a certain senior class has 800 students. That's 800. Among these students, there are 60 sibling pairs, each consisting of one junior and one senior. Let me understand that. So there are 60 sibling pairs. Basically, a brother and a brother, or a brother and a sister. One part of that sibling pair is in the junior class, one part, or that's the other part of the sibling pair is in a senior class. There are 60 sibling pairs. So there are 60 of the juniors and 60 of the seniors who are part of a sibling pair, right? Who are part of a sibling pair. So this is what I have. So I have like J1 to J1000. I have like S1 to S800 and 60 juniors. So let's say J1 to J60 are the juniors who are part of a sibling pair. I'm not going to list it out. And let's say S1 to S60 are part, or so the other part of that sibling pair. If one student is to be selected at random from each class, so since I'm selecting one student from each class, It's a single event, so I just have to take the probability of the first, take the probability of the second. What is the probability that the two students selected will be a sibling pair? So I want a sibling pair. So I want a junior and I want a senior. I'm stressing on the word and. I want a junior and I want a senior who are part of a sibling pair. So first way to work with it is obviously if I'm standing here and I see these two classes, 1,000 juniors, 60 of them part of a sibling pair, 800, 60 of them part of a sibling pair. I will go to the junior class and I will pick one person who's part of a sibling pair. So what is the probability of picking a person who's part of a sibling pair from the junior class? My total outcomes is 1,000. My favorable outcomes will be 60. Remember, I'm respecting the definition of probability. 60 would be my favorable outcomes. 1,000 would be my total outcomes. And what is the 60 by 1,000? 60 by 1,000 represents the probability of selecting a junior, selecting one junior who's part of a sibling pair. So let's say I have selected J1. You see, I'm visualizing. I've picked J1. The probability of getting any sibling, any junior who's part of a sibling pair should be 60 by 1,000. I'm keeping that person whom I selected J1. Now, I need to go to the other class and I need to find J1's sibling, right? If I need to go to the other class and find J1's sibling, it can only be S1. So what is the probability of getting S1 from the senior class? 1 out of 800. Because I need to match the sibling pair that I've selected from the juniors. And it's an and scenario. I need a junior from the first and I need a senior from the next. So 60 by 1,000 into 1 by 800. Some of you all have put 60 by 800 there, right? You'll have put 60 by 800. Then you're telling me for J1, there are 60 siblings, right? J1 has 60 siblings, which the question doesn't tell you. It tells you that every junior has a senior sibling, right? There are 60 juniors and they have 60 senior siblings. So 60 by 1,000 is the probability of selecting one junior, right? So that junior is J1. Now I go to the second class. I need to match J1. I need to pick a person who's J1's, say, sibling pair. And that would be 1 out of 800. That would be 60 divided by 1,000 into 800. So that would go. That would be 2 3s, 2 40s. That's 3 by 4,000. That would be my answer. 3 by 40,000. That would be my answer. Alpha. So again, see, your questions are going back to what I discussed in the beginning. Why I started with those pointers in the beginning. I said you can't violate the definition of probability. What is the definition of probability? It's favorable by total, right? I'm not selecting 1 out of 60. It's favorable outcomes on my numerator and my total outcomes on the denominator. What is the total outcomes when I go to the second class? 800. I have 800 people in front of me. Out of that, I need to select J1's sibling. That is S1. So it's 1 out of 800. So 9 out of 200. Okay. How did you get 9 by 2,000? 9 out of 200. C option was closed, but realized was doing something wrong. Okay. There's another way to look at this for those who want another explanation. So let's look at it another way. Okay. And then you'll understand this better as well. So let's list it out. I told you, once you visualize things, you can do wonders with this topic. Okay. You can understand this topic better. So I know there are 60 sibling pairs. So I'll call them J1, S1, J2, S2, J3, S3, J4, S4 till J60, S60. This is also possible. And now I'm looking at these 60 sibling pairs, right? Now think about it. Let's say I want to select J1 and S1 as part of the sibling pairs. I want specifically J1 and I want specifically S1. So what is the probability of getting J1? J1 would be 1 by 1000, because there's only one person who's J1. And what would be S1? 1 by 800. So this is the probability, 1 by 1000 into 1 by 800, of getting J1 and S1, the sibling pair J1 S1. Similarly, for J2 S2 also, it would be 1 by 1000 and 1 by 800. For J3 S3 also, it would be 1 by 1000 into 1 by 800. For J4 S4 also, it would be 1 by 1000 into 1 by 800. So I have 60 such scenarios. I can have this or this or this or this or this. So 1 by 1000 into 1 by 800, 60 times I can add them up. So I can just multiply this entire thing by 60. That's another way you can look at this question. Got it? So 60 divided by 1000 into 800. That would be your answer. That boils down to 3 by 40,000. This is another way you can visualize it. The point I'm making is you need to visualize the question. You see, when I wrote in the first scenario, when I wrote 60 by 1000, it is the probability. Remember, what does 60 by 1000 mean? It's the probability of getting one person who's part of a sibling pair. So that one person, I took it as J1, right? For me, that was my reference. J1 was who I picked from the class 1. 60 by 1000 was the probability. I go to the second class. I need to pick J1 sibling. I can't say 60 by 800 in the second class because J1 has only one sibling, S1. So it has to be 1 out of 800. The question is incomplete. What do you mean? Yeah, it doesn't matter, right? I'm not worried about this is guys, these are two completely separate classes, right? This is two completely separate classes. I am not picking two people from one class. That's why I said you're picking one student from each class. If you're picking one student from each class, for classroom J, it's 1. For classroom S, it's 1. I'm picking one from each group. So that's a single event. And it's asking me what is the probability of getting a junior and a senior. So I'm multiplying the two. Got it? Okay with this, guys? All of you all? I've given you two ways. But you see, again, what did I do? I approached the question from a very visual standpoint rather than looking at it from a mathematical standpoint. Right? So if I'm going to the second class, I know the total siblings are 60. If I'm going to the second class, I know the total siblings are 60, but I need J1's sibling, right? J1 sibling would be S1, right? So S1, the probability of getting S1 would be one person out of that 800. Imagine you are in class, you're in junior class and your brother is in the senior, right? If you have been selected as part of that sibling pair, if someone goes to the other class, they have to select your brother, right? There's only one brother that you have. You don't have 60 brothers, correct? So if you have only one brother, that one person out of my total, favorable by total, would be the probability of getting the senior. Got it? Yeah, I am. What I didn't understand your question, Shreyans. What do you mean? What about randomly? I am picking randomly, right? I mean, that is why I said I just took this as a reference point. I said 60 by 1000 in the process that I worked. I said, let me get back. J and S, this is 1000. This is 800. So I said I have 60 people who are part of a sibling pair here, 60 here. So 60 by 1000 was the probability of getting a junior who's part of a sibling pair. I just took, at the end of the day, I have to pick only one, no? So I just took J1 as a reference. You can also take J4, no problem. You want to take J60, no problem, right? So when I say 60 by 1000, what am I saying? The favorable outcomes are, it can be J1, J2, J1 or J2 or J3 or J4 or J5 till J60. I took J1 as my reference of sorts to understand the question better. So when I go to my second class, I need S1 or I need S2 if I took J2 or I need S3. So there's only one out of 800 to match the first, right? All right. Let's go to the third. I said probability can also be combined with other topics as well, right? So This is an example of how it's combined with other topics. I'm taking two questions where it's combined with other topics. And I think somebody asked, what will you do? Will you list out all the possibilities? I think that question is coming after this. I want all of you all to give a shot at this question. Try it out. Shivendu, junior, then senior, senior, then junior. I'm not going to worry. It gives me the same output, right? J1 and S1 and S1 and J1 are the same sibling pair, right? I can't count them twice, right? I'm selecting only one from a group, no? It's selecting only one from a group. So J1 from one, S1 from the other, right? I can't take S1 from one and J1 because it would give me the same thing, right? I can't count it twice. And it's not selecting from the same group. If you have from the same group and you have blue and green, then you have to consider green and blue as well. But these are from two separate groups. So if I'm picking J1 from one and S1 from the other, it's the same as picking S1 from one and J1 from the other. Yes, Rachita, this is a data sufficiency question. I'm assuming you'll know what the format is, right? Can you put in your answers in the chat window, please? Okay. Please forgive me if there is some background noise of my dog barking. So she's a Velcro dog, so she'll not leave me alone. I have to keep her in the same room that I am in. So if you hear a barking, please ignore. Okay. There's almost 70 people here. One more answers, right? We also have a session on data sufficiency, right? Um, One thing that I've noticed, even when I took the test, is there's a lot of probability and statistics based questions on the DI section, either in the data sufficiency and also a lot of statistics and probability questions on two-part analysis. Okay, so it's a very important topic from both a quant standpoint as well as a DI standpoint. Right. Okay, let's have a look at it. Each of the 50 students, I see most of you all have given me D, some of you all have given me C, some of you all have given me A, and so on. So let's look at it. Each of the 50 students participating in a workshop is either an undergraduate or a graduate student. If P is the probability that a randomly selected participant will be a female graduate student, as soon as you see such a question, you see there are two categories, graduate and undergraduate. So you're classifying based on graduation. And then you're also classifying based on gender, male and female. Immediately that should strike a chord and say, I need to set my entire question in the form of a 2x2 matrix. You can break it down individually as well, absolutely fine. But a 2x2 matrix will help you get that structure towards working. So for those who use the 2x2 matrix, great. So I have a graduate, non-graduate, or let's say graduate, undergraduate. I'm so sorry. Let's say graduates, undergraduates, total, male, female, total. So each of the 50 students participating in a workshop. So I know my total has to be 50. Is either a graduate, undergraduate, or a graduate. If P is the probability that a randomly selected participant will be a female graduate, it's that block. Is P less than half? So what is P? P is the probability of getting a female graduate. And they're asking me, is the probability of getting a female graduate greater than half? Normally, what I do when I work with a data sufficiency question, I spend a lot of time on the question stem. I try to break down the question stem as far as possible. So I would ask myself, what is the probability of getting a female graduate? It would be the female graduate divided by the total. That's the definition of probability. The favorable outcomes, what is in this block, divided by the total outcomes, that's 50, should be greater than half. I'm doing this extra step. I'm not leaving it at this point. I want you to observe that. I'm breaking it down further. 2 ones are 2 25s are. So the question is basically asking me, is that female graduate greater than 25? That's the question. Right? Now I would go into my first statement. Of the participants, of the total, 24 are females. Now think about this, guys, right? If 24 are females, and I want to calculate this block, female graduates, and I want to see whether that value is greater than 25. If the total females is 24 itself, then the female graduates can be a maximum of 24 or less than 24. So it's going to answer my question with a definite no, because I know the female graduate should be equal to 24 or less than 24. It's going to answer my question with a definite no, and a definite no is sufficient for me to answer. So AD would be the two possibilities. Second, of the participants, 18 are graduate students. So of the participants, 18 are graduate students. So this would be 18. Now again, I need to calculate for that block. The female graduates can only be less than or equal to 18. I can't have this to be more than 18. And so the female graduates will definitely be less than 25. It gives me a definite no, sufficient for me to work. Delta. Got it? I broke it down this way. So some of you all would have, got to this point and then continued with the question done 24 by 50 maximum and so on. What I did, and this is something that I want you to also develop when you work with the data sufficiency question, I broke down the question. So if somebody gives me what is the probability of getting a red marble, I will write down red divided by the total. Right? What is the probability of getting a female graduate? Female graduate divided by total is greater than half. So the question is basically rephrased to, is the female graduates greater than 25? All right. A good example of how a data sufficiency question is going to be that integrates probability along with another topic. Always single event probabilities might be integrated with other topics as well. Right. I hope this was a pretty relatively straightforward question, not too difficult. People still got it wrong with C, some with E, some with A, right? I think most of you all didn't put it in the table, so you all missed out on the second that 18 would be a limiting factor for the female graduates, right? So let's move on to the last question of this bit, single event probabilities. And this is where it's going to take it a notch higher, integrating a little bit of number properties as well, along with the concept of probability. Remember, single events should always be looked at as favorable divided by total. Figure out the denominator, figure out the numerator, divide the two. 2 minutes start now. Guys, please don't type in the answer in the chat window until I ask you to do so. Okay. For those of you all asking about the absolute value session, yes, the absolute value session is going to cover some extra things that is not there in the previous video, right? But I think it's, you'll have to wait and see when we schedule it, right? But the old video will absolutely do fine as well. Guys, this session will go quite long, right? So just ensure that you have something to eat or some water at the side, because I want to, I told you it's going to be a deep dive. So it's absolutely fine if you're a little tired to log out, and please have a look at the video recording later, right, on GMAT Club. I will give you a 2-minute break after this, right? And I'll address a couple of questions also in that break. Okay, you can start putting your answers in the chat window. 60 by 96. Okay. So this is the example where someone said, right, that do I have to sit and count the numerator and denominator? Of course not, right? They would give you something where you'll have to think about it logically as well. I'll touch upon a little bit of number properties as well. Maybe you can take this as a advice on number properties, but I'll show you two ways to work with this. Yeah, Jaiwal, it is exactly a number property question that integrates probability towards the end, and you'll find this as the pattern. That's the point I'm making, right? Single event probabilities will be combined with other topics. When we go into complex event probabilities, that is where you're going to find out the core probability questions. That's going to be the second bit of our discussion. Okay, I'm going to do a deep dive in this topic, right? I'm going to leave no stone unturned. I'm going to put a video out there so that y'all can go back and rewatch, and it should be more than enough for you to work with any probability question of the GMAT. There's another reason why we do this topic towards the end, because it integrates a lot of word problem skill set, reasoning skill sets, and other topics as well, right? But popular demand, most of you all wanted probability and permutations, and also keeping it too algebraic. Also, I felt with absolute values as a follow up was a little bit too much of algebra, so I decided probability. Now let's have a discussion, please. I see some of you all have given me an answer. So for those of you all who didn't get an answer, right? Can you tell me where you all got stuck? Okay, so that when I'm explaining the question, I can address that as well, right? Can you all also quickly type in the chat window? Where did you all get stuck? Did you find this question hard? It is a hard one. It's classified as a hard question. So for those of you who didn't get an answer, no problem. Tell me where you got stuck. What was the difficulty aspect? What is the difficult aspect? Multiple values going on. Finding the pattern was time consuming. 2, 4, 6, 7, 8. Okay. So two things I want you to learn. Okay. And this is, for number properties. Whenever you work with number property questions, there are always two kinds of approaches that you can use. First, you can analyze and reason things out, but your analysis has to be really spot on and correct. And second, you can put in values and look for patterns, but you have to understand how patterns work, and you'll have to observe the patterns there. So let me explain how I would do it first. So if an integer n is to be chosen at random from the integers 1 to 96 inclusive, so I have 1 to 96. So I quickly have what my total outcomes are. There's absolutely no problem with this. Agree? Total outcomes 96. The question is asking me, what is the probability that n into n plus 1 into n plus 2 will be divisible by 8? That means I have to figure out what values for n, when I substitute here, will give me n plus 1 and n plus 2 to be divisible by 8. For those who are well versed in the topic of number properties, you would have realized that those are three consecutive values. But everything depends upon the values for n. So what am I going to do? I'm going to first approach it from an analysis standpoint. I'm going to cater to both kinds of test takers. Test takers who work with analysis, and test takers who also approach these questions by looking at values and patterns. Okay, I'm going to attack it both ways. So let's work with analysis first. I need to figure out what are the different values of n that are going to satisfy that equation. So the values of n here, n into n plus 1 into n plus 2, will depend upon the nature of n. N can be either 1, 2, 3. Basically, it can either be an even or an odd. So let me analyze this. If n is an odd, since they are consecutive, n plus 1 should be even and n plus 2 should be odd. And now I'm going to ask myself, okay, if I put the value of n as odd, n becomes odd, n plus 2 is also odd, and I have an 8 on the denominator, and 8 is basically 3 2's. This odd and this odd is never going to give me any 2's to cancel out this 8. So the only way I can have n into n plus 1 into n plus 2 be divisible by 8 is if this term n plus 1 is divisible by 8. That is, if n plus 1 is a multiple of 8. If n plus 1 is like an 8 or a 16 or a 24. And if n plus 1 is an 8, n will be a 7 here. Remember, n plus 1 has to be a multiple of 8. So n has to be 1 less than a multiple of 8. And 1 less than a multiple of 8 will be 7, 15, 23, and so on. How many multiples of 8 do I have? From 1 to 96. 12 8s are 96. I have 12 multiples of 8. So all those 12 multiples of 8 minus 1, 1 less than them, would be all the odd values of n that will satisfy this condition. So the odd values of n would be 12. That's the first. Now what if n is even? If n is even, n plus 1 will be odd, n plus 2 will be even. Now think about it. I need this to be divisible by 8. N will give me a 2. N plus 2, if I take n as 2, this will be 4. 2 into 4 will definitely give me enough 2's to cancel out the 8. If I take 4 here, this will be 6. 4 gives me 2, 2. 6 will give me another 2. That will be enough to cancel out the 8. If I take 6, that will become 8. So basically, any even value that I take, n into n plus 1 into n plus 2 will always be divisible by it because I get enough 2's to cancel out the 8. So all even values will work for n. And how many even values? If I have 1 to 96, half of them would be odd, half of them would be even. So n there would be, even values would be 48. So my total outcomes now is 96. My favorable outcomes would be 48 plus 12, which is 60. 12 5s are, 12 8s are. That gives me 5 by 8. Got it? This is one way to look at it, the analysis route of working. Now let's look at the other route where people have used numbers. So again, 1 to 96, the total outcomes were 96. And you need n into n plus 1 into n plus 2 to be divisible by 8. Now, for those of you all who went with numbers, remember what you have to keep in mind when you work with numbers, you have to observe patterns. And you have to have a very good stronghold of the understanding of that topic. Divisible by 8 means it's perfectly divisible. It leaves a remainder 0. Right? So whenever I write remainders are always cyclic in nature. Right? When you divide something by 8, you'll get a remainder of 0, 1, 2, 3, 4, 5, 6, 7. Again, it'll be 0, 1, 2, 3, 4, 5, 6, 7. So if n into n plus 1 into n plus 2 is divisible by 8, if I can plug in values for one entire cycle up till 8 and observe the patterns for that cycle up till 8, that same cycle beyond 8 is going to repeat. Yes? So if I put n is equal to 1, 1 into 2 into 3 is not going to be divisible by 8. I put n is equal to 2. 2 into 3 into 4 is divisible by 8. If I put n is equal to 3, 3 into 4 into 5 is not divisible by 8. If I put n is equal to 4, 4 into 5 into 6 is divisible by 8. So for the people who are slightly lazy and did not list it out for one entire cycle of 8, you all would have stopped here and you all would have picked half. So people who picked half, you all didn't entirely finish that cycle. right? And you'll also, people who picked half in an analysis process would have just figured out that it works for even, and you'll have ignored the odd numbers entirely. Finish a cycle. Remember, it's cyclic in nature. So if you do one cycle of 8, that same pattern should repeat for the second cycle of 8, third cycle of 8, fourth cycle of 8. So if n is equal to 5, doesn't work. N is equal to 6, 6 into 7 into 8 works. N is equal to 7, 7 into 8 into 9 works. N is equal to 8 also works. So with one cycle, it's working for 1, 2, 3, 4, 5 numbers. And I have numbers up till 96. So basically, it's 8 such cycles. For one cycle of 8, it's working for 5 values. So for 8 such cycles, how many values will it work for? 1, 2, 3, 4, 5, right? So how many, for 12 such cycles, sorry, for 12 such cycles, how many values will it work for? So 5 in one, 5 in the next, 5 in the third, and we have 12 cycles of 8. That would be 12 times 5, which is 60. So 60 divided by 96 will be 5. Right? Here itself, you could have stopped and got your answer, but it's better for you to finish the cycles and work. This is the other way of working with number property questions, to plug in values. But if you're plugging in values, you have to remember, I need to be patient to look at a pattern. And normally you plug in values up to the denominator. If I change this question to 24, no, I wouldn't go with this approach, to be truthful. I would still go with the analysis process. But you see how they integrate probability with the other topics. And that's the point I'm making. Your job is to count what is there in the numerator count smartly, and count what is on the denominator smartly, and divide the two, right? Of course, right? I mean, if you work with the analysis process, I would prefer analysis. For people who want to set it up, remember guys, for those who are saying this is a better process, what if I give it to 24? You're going to tell me you're going to write all numbers up to 24 and check? You can, but not a very feasible process. That's the biggest downside towards putting in values. Okay. So always go with the analysis process, right? So this is the first bit, right? The important introduction towards single event probabilities and how you need to list out numerators and denominators. We're going to go into core probability now. Next, the harder levels of questions, the AND probability and the OR probabilities. Before that, a 2 minutes break, and I'll address certain questions, and you can have a quick bite to eat, drink some water, and then we'll continue. Guys, please care to click on the like button if you like the video or like the class so far. It helps, to in the algorithm as well. So please do that. Any other methods to solve this? What other method? I've given you both that you can, right? I know the property, but I know n into n plus 1 into n plus 2 will always be divisible by 8 when n is even. So if you know that, then getting 48 would be easy. That's a property. See, I don't want to dump properties in your head, to be very truthful. And that's a property, obscure property that, GMAT will expect you to figure out, not expect you to work, right? So, okay. Any advice for fellow MSRAT alum taking the test in 4 days? Pavan, if you've taken a practice test, your score is going to be in and around that, right? So if you're hitting target scores, that you're targeting, right, then you should be able to do absolutely well on test day. Okay, expect maybe a 20-point differential, because it's test day. The questions will be a tad bit tougher than the official questions, and pressure also comes into play. But I think if you're doing well on the practice test scores, all you have to do is keep in mind that decision making will play a very important role for you in 4 days, right? How you decide to approach questions the right way, how you be in control of the test, right? I always say that you should always be in control. You should never let the test take control of you, right? So if you're in control, you make better decisions, you should be good to go. For those of you all who want to contact me, guys, this is not the right platform for it. I think in one of my videos, GMAT Club has been very kind to put in my LinkedIn profile and a link there, so you can just see one of the videos and reach out to me on my LinkedIn profile, right? Yes, I do personal tutoring as well, right? So if you want to reach out to me, you can reach out to me on the LinkedIn platform, right? This is more, it's something that I'm very grateful to GMAT Club, and I want to put in content there that's accessible by everyone. People who cannot afford personal tutoring as well, and GMAT Club have been very kind enough to give me that platform, right? So that is why I do this for them. Thank you, Jaiwal. Thank you for your for your kind words on the videos, right? Yes, that's what I said, right? For if you have n as odd, then only the 8k minus 1, right, would be the values that will satisfy. Simple, guys. You don't need to look at it algebraically, right? For those of you all wondering, I just looked at this as an odd, this is an even, and this is an odd. Now, two odd numbers can never give you anything to cancel out the 8, right? So I just said that n plus 1 has to be even. So if you want me to write it, n plus 1 has to be divisible by 8. So n plus 1 should be 8, 16, 24, 32, all the multiples of 8 up to 96. And that is n plus 1, no? So n should be 7, 15, 23, for those of you all who didn't understand how I got the odd values. Yes. Okay, so let's continue. I'm hoping all of you all grabbed a bite to eat, some water. I told you it's going to be a long session today, so please feel free at some point to drop off if you're tired. The video is going to be uploaded on GMAT Club. You can, and in your comfort of home, tomorrow's a holiday. You can look at the video and make your notes from it. All right. All right. So let me shift now to my sketchbook, and let's look at complex events first, then we'll do the or probabilities towards the end. Okay, let's look at this because I think or probabilities will be easy for you to comprehend. It'll be more visual and you'll be more tired late into the evening. So let's do complex events first because that will require a little bit of setup. All right. Okay, so complex events. So quick recap, right? What have we done so far? I said definition of probability has to be respected, favorable by total. Total should always be the all the outcomes, the set of all outcomes, possible outcomes. I said that you need to know how to work with Venn diagrams. We'll use that in that or probability coming later. You need to know how to arrange alphabets in a word. That's going to be a part that we're going to utilize in the complex event probabilities. And fourth, I said, when you work with questions here, visualize the question. Set up like a visual component, a diagram. Put a stickman figure to represent, yourself in that question, right? And then break the question down from a visual and logical standpoint. That same thing carries forward here. Also, I said the word or means addition, the word and means multiplication, right? So let's continue from here. Complex events. I said complex events are when you work with more than one object, or you're selecting more than one object from a group. Now the question will be is, Aditya, why are we making a complex event like this? Why can't we solve every question based on the definition of probability? Find out smartly what will be the favorable outcomes, find out what the total outcomes, and divide the two. Why can't we break it down for all questions? Why do we have to learn this? So let's take an example. Okay, let's say this time we toss one coin two times. Okay? Or we toss two coins at once. It's the same. Let's say we toss one coin two times. So, my question to you all first is, if I toss one coin two times, what will be my total outcomes? What will be all my outcomes? And how many total outcomes will I have if I toss one coin two times? Quickly, chat window. I'll repeat. If I'm tossing one coin two times, how many total outcomes will I have? And what will be the total outcomes? I'll have four total outcomes. The reason for that, for the first toss, I'm going to get two outcomes, head and tail. For the second toss, I'm also going to get two outcomes, head and tail. So it's two outcomes for the first toss and two outcomes for the second toss. Remember, I said it's similar to the example that I took. If I have a set A, 1, 2, 3, 4, I have a set B, 5, 6, 7, 8, 9, the total outcomes will always be the product of the individual outcomes. So head and tail, two outcomes, head and tail, two outcomes, so a total of four outcomes. And normally, probability, the definition says if you're able to list out the outcomes, great. You can easily solve it using its definition. So the four outcomes I would have would be HH, HT, TH, and TT. So here, totally fine for me to list it out. And now, if somebody asks me, what is the probability of getting two heads? I would directly say, great, I have everything listed out 1 out of 4. And what is the probability of getting a head and a tail? Remember, I'm asking you what is the probability of getting a head and a tail. I'm not specifying the order. So, what are my favorable outcomes that give me a head and a tail? That's 2 out of 4. And if I ask you what is the probability of getting head on the first toss and tail on the second toss, then obviously I'm specifying the order to you. If I'm specifying the order, that's only one possibility out of 4. So here I could easily list out things and work with. Even if I toss one coin 3 times, it would be feasible for me to list out the possibilities, right? So let's say I'm tossing one coin 3 times. If I toss one coin 3 times, it would be head or tail for the first, head or tail for the second, and head or tail for the third. So it would be two outcomes for the first and two outcomes for the second and two outcomes for the third. That would be a total of 8 outcomes. Let me list it out. Now, here listing out may become a problem, but it's doable. It's absolutely doable. So let's say H, H, H. Let's keep this H as a reference and let's list out all the outcomes with that head. So head, 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 tail, head, tail, head, and head, tail, tail. So with this head, there are 4 outcomes with the other 2. Now I'll take it with the other tail as well. So tail, head, head, tail, head, tail, 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 head, and tail, tail, tail. So if I'm able to list out 1, 2, 3, 4, 5, 6, 7, 8, my job becomes easy because then I can count out my favorable outcomes very quickly. So what would be the probability of getting 3 heads? The probability of getting 3 heads will be 1 out of 8. Simple. Because I've listed it out, I'm boiling it down to a baseline definition. If I ask you what is the probability of getting 2 heads and a tail, 2 heads and a tail would be 1 favorable outcome, 2 favorable outcomes, 3. That will be 3 out of 8. And if I say what is the probability of getting head on the first toss, head on the second toss, tail on the third toss, I'm specifying the order, then it has to be only 1 outcome. That will be 1 out of 8. So even if I toss one coin 3 times or I toss 3 coins at once, it's possible for me to list it out. But now I make it even more problematic. What if I toss one coin 5 times? If I toss one coin 5 times, how many total outcomes will I have? Think about it. If I toss one coin 5 times, how many total outcomes will I have? Guys? 2 to the power of 5. 2 times 2 times 2 times 2 times 2. That's 32. I cannot logically write down 32 outcomes and work with it and count out which one gives me 3 heads and 2 tails and so on, right? That would be absolutely pointless for me to do so. right? And that is where the baseline definition of probability, the single event probability, fails you. When you have more iterations that are being used, there are more objects that are being used, it becomes very difficult for us to list out all the total outcomes, the favorable outcomes. So what do? We don't use this baseline definition directly. Instead, we use complex events. So what does it say? Whenever you have a complex event, you're picking more than one object, or you have more than one object to work with. The probability of a complex event, everything should boil down to the usage of this formula. The probability of any complex event is the product of probabilities of the individual events. It's the product of the probabilities of the individual events that comprise the complex event, that make up that complex event, into the arrangement. I will explain the usage of this formula using this example itself. If you see a complex event, if you see an AND probability, you have to boil down your working to the usage of this formula. And this is the only thing that I would use across all questions when I have an AND probability. And you'll see how I'm going to use it. The probability of any complex event is the product of probability of the individual events that comprise the complex event into the arrangement. This complex event should always be a set of alphabets. It should always be a set of alphabets that represent the question. You should always learn to use alphabets to your advantage there. Set up the complex event as a set of alphabets. So if the question asks you, what is the probability of getting a blue and a green? Then I would write it as P of BG. What is the probability of getting two kings and a queen? Then I would say P of KKQ. This formula helps us bypass this process of listing things out. I don't need to list things out from here. So let's work with it. Let's see how to use the formula using these three examples that I've set up. Let's say the question asks me, what is the probability of getting 3 heads when you toss a coin 3 times, or you toss 3 coins at once? So I will represent the complex event as H, H, H. I'm calling the heads as H, the tail as T. Now, H, H, H. The probability of a complex event is the product of probability of the individual events that comprise the complex event. The individual events are the first head, the second head, and the third head. So the probability of getting a head would be half. So half times half times half into the arrangement of these alphabets. Right? It's 3H, so obviously there's only one arrangement, but I would write it in terms of a factorial. That would be 3 factorial by 3 factorial. You count the alphabets individually, write down that factorial divided by the repeating letter factorials. That would cancel to give me 1 by 8. Exactly the same answer I've got here. You'll understand the meaning of the arrangement and what the arrangement represents in the next example. This is a very good example to understand the arrangements better. So if somebody asks me, what is the probability of getting 2 heads and a tail? Normally the mistake people make here also, they'll just do half, half, half. They'll say 1 by 8. That's not the answer. The probability of 2 heads and a tail. So I'm representing the complex event as HHT. So the probability of a complex event is the product of probability of the individual events into the arrangement of those alphabets. So it's half times half times half into the arrangement of HHT. So 3 factorial divided by the 2 factorial for the 2 H's repeating. And 3 factorial by 2 factorial, if I simplify, will give me 3, which is 3 by 8. Now, what does this 3 factorial by 2 factorial, that is 3, represent? What does the arrangement represent? The arrangement represents all the different cases where I can get 2 heads and a tail. You see, they have not specified the order for me. They have not told me that head should be on the first, head should be on the second, and tail should be on the third. They have told me I just want 2 heads and a tail. So what are the different cases? I can have head on the first, head on the second, tail on the third, head on the first, tail on the second, head on the third, or tail on the first, head on the second, head on the third. There are three cases that are applicable to this complex event. So instead of me listing the cases down, the factorial takes care of that for me. Right? Why am I getting three? Because there are three scenarios: head on the first, head on the second, tail on the third, head on the first, tail on the second, head on the third, tail on the first, head on the second, head on the third. So the factorial takes care of all the internal possibilities where that complex event can occur. 3 by 8. And finally, probability of head on the first toss, head on the second toss, and tail on the third toss. Here they are specifying the order. Now think about it, right? If the order is specified, they're telling me H has to be on the first, H has to be on the second, T has to be on the third. If the order is specified, I will not bother about the arrangements. So remember, whenever the order is never specified, the arrangements have to be taken into consideration. But if the order is specified, I have to ignore the arrangements. So this will be just half into half into half, which is 1 by 8. Exactly the same answers that I've got here. And it's this process that we can use throughout, right, in all probability questions with complex events. I'm going to explore more, right? So people ask me what is with replacement, without replacement. I'm going to bring all of that now in our discussion. So what did I say? Whenever you have a complex event, first thing is you have to identify the complex event. You need more than one object. You're selecting more than one object from a group. Anytime you work with a complex event, boil it down to the baseline formula. The probability of any complex event should be the product of probability of the individual events that comprise the complex event into the arrangement. And that complex event, I would encourage you to write the complex event always as a set of alphabets. Right? When you write it as a set of alphabets and you're smart with the alphabets, you'll be able to visualize the question and set up your math in a very efficient way. Got it? So let me write down the formula. And let's take some examples and see how we can utilize it in all procedures. Balls in a bag, tossing of a coin, selecting people from a group. You see, I'm never going to deviate from this process. The probability of any complex event is the product of probability of individual events that comprise the complex event into the arrangement. Remember, the arrangement is always the arrangement of the alphabets that make the complex event. It gives you all the different scenarios that apply on that complex event. If the arrangements are not specified, if the order is never specified, you have to consider the arrangements. If the order is specified, I don't need to worry about this. Right? So can we please take an example of 5 coins and get the probability of getting heads on the first 2 tosses? Great. I'm going to take an example here. Let's, instead of taking 5 coins, let's do 3 heads and 2 tails. Suppose I tell you now, you're tossing a coin 5 times. Okay, you're tossing a coin 5 times, and I'm asking you, what is the probability of getting? Guys, I'm going to build from here, okay, and you'll see I'm going to apply one straightforward usage across all questions. Probability of getting exactly 3 heads and 2 tails. So same thing applies. Visualize the question, reason things out, read the question, then set up your logic before going into the math. Many test takers I see will directly go into writing the fractions. Don't. Visualize the question 5 times. I'm tossing a coin 5 times. So clearly this is a complex event. A complex event expects me to set things up in terms of alphabets. What is the complex event they're asking me to solve for? Exactly 3 heads and 2 tails. So I'm going to write that. 3 heads, 2 tails. HHHTT. So that's going to be what? The probability of any complex event. There's only one case here. I don't need to worry about multiple cases because I know the internal cases will be taken care of with the factorial that I'm bringing in. So probability of HHHTT will be the probability of the individual events that comprise that complex event into the arrangement. That will be half times half times half times half times half to the power of 5 into the arrangement of these alphabets, HHHTT. So I'll 1, 2, 3, 4, 5 factorial divided by 3 factorial for the 3 h's, 2 factorial for the 2 t's. Now I can simplify. So this would be 5 times 4 times 3 factorial by 3 factorial into 2 factorial. This cancels. 2 ones are 2 2s, so that will give me 10. So that will give me 10 by 32, which will be 5 by 16. Right? That should be my answer. Right? So somebody asked me heads on the first two tosses, you can try it on your own. I think you should get pretty much the same answer as well. Right? I'm using for everything, right? So you don't need to worry about it. You can use it even if you're rolling two die, right? The point I'm making is what if I'm working with more than one object, whatever the question's asking me to solve, I'm going to represent it as a complex event. Didn't understand the arrangements, Jawal? We went to Delhi, we looked at Delhi, right, previously, and we looked at the example of Aditya, right? What did we do? We counted the alphabets individually, wrote down that factorial. And for Aditya, we counted the alphabets individually, wrote down that factorial, and divided by 2 factorial for the 2 A's repeating here, right? So here I have a word HHHTT, right? So I'm working with the arrangements there. I'm counting the alphabets individually. I'm writing that factorial down. That's 5 factorial divided by the repeating letter factorials. That's 3 factorial to 2 factorial. And now you can explore, right? Don't do it now. We'll do it. You can do it post the session. You can explore with whatever combinations you want. I will use a couple of more examples here, and I'll give you different variations. And I'll also give, using those variations, I will give you some guidelines also of how you need to set things up. Okay. So let's take another example. Let's say you're tossing. Let's take an example where you have a real life scenario, right? Let's say the probability that it rains on any given day in Bangalore is 0.7. Okay, the probability that it rains on any given day in Bangalore is 0.7. So my question, what is the probability that it rains on exactly 3 days in a 5-day work week? Guys, you see what I'm trying to do? I'm trying to integrate the same process into a real life example now, right? So I want you all to break down the question. And I'll repeat the question. The probability that it rains on any given day in Bangalore is 0.7. And my question, what is the probability that it rains on exactly 3 days in a 5-day work week? You don't need to do the calculations with the decimals. As long as you write it in terms of powers and tell me what the factorial is, that's fine. But I want all of you all to take like 30 seconds and set it down. Don't directly write down the math, okay? I want you all to spend time on the question, understand it, understand the meaning of what I've asked, figure things out logically, then set up your logical scenario, and then break it down using the math. Okay? Never rush through directly with the math here. Understand the question, guys. Okay? Understand the question. It's key to solving of this topic. Okay? And I'm going to use these questions to write some guidelines. So please focus on the question. Good. Now, this is how I want you all to break it down. The probability that it rains on any given day in Bangalore is 0.7. So clearly the probability that it does not rain is 0.3. Why am I writing that? Because it says the probability that it rains on exactly 3 days in a 5-day work week. So, what is the question asking me to consider? It's asking me to consider a 5-day work week. And it's asking me to find out the probability that it rains on exactly 3 days. Now, it has to rain on exactly 3 days in a 5-day work week. It should rain on 3 days, but it should not rain on the other 2 days, right? For it to be raining on 3 days in a 5-day work week, it is conditioned to it not raining on the other 2 days, right? So I would write this as P of rain, 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 not rain, not rain. And now I would break it down for people who didn't get the answer, who got like 0.7 into 0.7 into 0.7, that is 0.343. You all didn't read the question carefully. The question was a 5-day work week, and you needed to rain on exactly 3 days in a 5-day work week. So if it has to rain on 3 days, it should not rain on the other two. So that would be 0.7 into 0.7 into 0.7, 0.7 cube into 0.3 square into the arrangement, because I don't know whether it's going to rain on the first, second, third. It can rain on any of the 3 days. So I need to worry about the arrangements of those alphabets. That will be 5 factorial divided by 3 factorial into 2 factorial again. Make sense? I'm not going to solve it. I'm just taking this as an example. Okay, so yeah, I'll leave that solving up to you. Right? But this is exactly what you would. If you get a question like this, they would leave the answers in terms of powers like this. Okay, maybe they will simplify this, right? 5 factorial by 3 factorial, 2 factorial, but they don't expect you to sit and do the solving. You don't have a calculator in the quant section. You have it in the DI section though, right? So this is what you do. See, I'm taking the same ideas into a real life question as well. And I want you to focus on these guidelines. Remember, the first step while working with complex events is to read, comprehend, and visualize the question. Most of you all didn't do it, right? Because you just read it as 3 days, so P of RRR. Remember, it's 3 days in a 5-day work week. So read, comprehend, visualize. I'm going to write something here, set up the visual component. I'll tell you why. And we use other examples. Here, I don't need any visual component to be truthful. And third, once you set up the visual component, list out the logical cases. This should be your first 3 steps whenever you're working with a complex event probability. You should not get down to the math very quickly. If you do that, you're going to definitely go wrong. Okay. This first 3 steps are key towards the math going right. So ensure that you focus on those 3. Now let's take another example and then go into example where you balls from a bag and cards from a deck. Let's do balls from a bag rather than cards from a deck. Okay, so let's say the probability that I go in late to office on any given day is half, right? The probability, somebody said, what about it rains 3 days and 2 of the raining occurs on the first 2 days of the week? Then I will keep RR as the first 2. I'll fix those positions YY. And for the remaining R and the 2 ends, I will take the arrangement. Good question, right? So YY said, what if I wanted to rain on the first 2 days? So you're specifying that it rains on the first 2 days. So the other 3 days, I know 1 should be rain and 2 should not be rain, right? So these positions are fixed, right? You want it to rain on the first 2 days. So I'll keep those positions at fixed. I will write down 0.7, 0.7, 0.7, 0.3, 0.3, but I will take the arrangements only of the R and M. All right, it's a good question that you asked. It's similar to how you would arrange objects on chairs, no? If I say you have to put A on the first chair and B on the second, you would normally keep them fixed and then work with the arrangements of the others. Same logic applies here as well. Okay. Okay, coming back to my question. The probability of me going in late to office on any given day is half. The probability that I go early into office on any given day is also half. So I go late or I go early. I don't go on time. So my question: what is the probability of going late to office for at most 2 days in a 5 day work week? Again, I'll give you all 30 minutes to work with it. I want you to again focus on the details of the questions giving you. Okay. Understand the question. Ask yourself in your mind, if I have to go late for at most 2 days, what are the scenario? What is the meaning of at most? So, what are the different scenarios I have? Focus on that logical setup. Then focus on working with the math. Yes, RR is going to be considered as fixed in the first two positions to ship because that's the condition. He said he wanted the raining to happen on the first 2 days, right? For those of you all who have done permutations and combinations, the way I've been taught probability is to look at it from a permutations aspect. Most of you all would have been taught probability from a combinations aspect, and that's where if you try to look at it as a combination aspect, it's very difficult for you to work with questions where you're tossing coins, right? You can do it while selecting people, but tossing coins become an issue. But if you work with it from a permutation aspect, you can use it for all kinds of questions. Okay. Focus on the question, guys. Focus on understanding the question. Focus on the logic and then set it up. Vivek, I think you need to focus on understanding what at most two means. Okay. Okay. Guys, I want you to learn to, like I said, focus on understanding the question because everything, the logic, the working lies in you understanding the question well. That's why I took 40 minutes in the beginning to put in certain ground requirements. Ensure that you read it carefully. Okay. So I've given you the probability of late, given you the probability of early, and I need the probability of going late for at most 2 days in a 5 day work week. What is the meaning of at most 2 days? I can go late for a maximum of 2 days, right? I can go late for a maximum of 2 days. That means I can go late on 2 days, or I can go late on 1 day, or I can go late on 0 days as well. And that's the scenarios I have to write down here. There are three scenarios I have to work for. Going late on 0 days, that is, if I go late on 0 days, on all the 5 days, I'm going early. Or I can go late. You see how I'm using the word or? The or means I have to add them up. Or I'm going late on exactly 1 day. Or late on 2 days, early on 3. So what am I doing? I'm listing out my logical cases. I am not getting down to solving the math. Now, after I've listed out my logical cases, I will break things down. So this will be half to the power of 5 into 5 factorial by 5 factorial. I don't need to write it, but I'm just showing it to you. That would be 1 by 32. This would be half again to the power of 5 into 5 factorial by 4 factorial, which will be 5 by 32. And finally, half to the power of 5 into 5 factorial by 3 factorial into 2 factorial, which will be 10 by 32. Right? So I'm going to add everything up because I have an OR scenario that exists between everything. And that would be 16 by 32, which is half. That is my answer. See again, I focused on using the process of a complex event. I focused on figuring out the logic of what the question says. And then I need to break it down this way. Okay. I wanted to hold on to this. Very, very important. I'm going to leave these guidelines at the side. Um, and I'm going to add to those guidelines. Any doubts, guys, before I move forward? I'm going to now pick balls from a bag, cards from a deck. I'm going into people from a group, and so on as well. People ask me, what is the most difficult topic you have on the GMAT? They expect me to say inequalities, absolute values, and probability. But I always, say it's always word problems. The word problems are the most difficult. Why? Because you need to understand the questions. You need to read and process information first before you can go into the math. So let's take an example now, right? I have 2 blue, I have 3 green, I have 4 yellow. I'm going to go into an example with balls in a bag, right? Now, when you're selecting objects like balls in a bag, cards from a deck, people from a group, your selections can be done in one out of 3 ways. So far, we looked at coins, we looked at late, early, raining, not raining. I didn't have to worry about selections there, right? Now, I'm working with selections. So, whenever you're selecting objects from a group, your selections can be done in one out of 3 ways. You can select objects one by one with replacement. You can select objects one by one with replacement. You can select one by one without replacement. Y'all would have studied this as independent and dependent. I'm not going to go into jargon like that. One by one with replacement means you pick one, visualize it in your head. Pick one, I keep it back, and then pick another. One by one without replacement means I pick one, I hold on to it, then I put my hand again and pick another. And the third selection would be a simultaneous selection. When they give you something like you're selecting 2 balls or 3 balls at random, that would always be a simultaneous selection. When they say you're picking 2 balls at random and they don't tell you whether it's one by one with replacement or one by one without replacement, it has to be a simultaneous selection. Basically, you're putting your hand inside the bag, you're picking 3 balls at once, right? You're scrounging in the bag, you're picking three balls at once. But to be very truthful, right? When you see a simultaneous selection being done, the rule is you treat a simultaneous selection exactly the same as one by one without replacement. You treat a simultaneous selection exactly the same as one by one without replacement. So, in a sense, we only have 2 kinds of selections: one by one with replacement, one by one without replacement. A simultaneous selection should be treated as exactly the same as one by one without replacement. Got it? So anytime you see at random 2 balls at random, one by one without replacement. So now with that, let's move on to an example. So let's take examples. Again, like I said, I'm going to visualize the question for some of you. One of you all asked me, can you do with replacement, without replacement? So this is what I'm going to do to explain. Remember, guys, simultaneous one by one without replacement, right? By default, simultaneous selections treat them as one by one without replacement. So when I see a question like this, right, where I'm making selections, if it's possible, always I would draw my visual component. So I will say this, I'm standing in a room. I have this table in front of me where there is a big bag and there are 2 blue, 3 green, and 4 yellow balls in the bag. And I'll put a stickman figure. This is my visual component. I'm working with this. Now, let's say the question asks me, what is the probability of picking of or what is the probability of getting a blue and a green when you pick two balls from the bag one by one with replacement? So the question says, what is the probability of getting a blue and a green? So I'll put it as alphabets: blue and a green. When you pick two balls from the bag one by one by one with replacement. So now let's visualize this. I'm going to treat it exactly the same as what I did so far. The probability of any complex event is the product of probability of individual events into the arrangement. So the probability of BG will be the probability of getting a blue. That will be 2 by 9 because there are two favorable outcomes and there are 1, 2, 3, 4, 5, 6, 7, 8, 9 total outcomes. You see how I'm using my visual component? The visual component will help me set up the math well. So 2 by 9. But this is 1 by 1 with replacement. So whatever blue I've picked, I'm keeping it back in the bag. Now I need a green. So again, my favorable outcomes, my total outcomes will still be 9. My favorable outcomes will be 3 into the arrangement of B and G. That's 2 factorial. They have not specified in which order. So I can pick either blue on the first, green on the second, or green on the first, blue on the second. It is still two different, right? So BG or GB. So the 2 factorial takes care of that possibilities for you. Okay, somebody says press on the keyboard to make it bigger. Great. Thank you. Thank you for the advice. I will. Okay. So into 2 factorial. Now I can simplify this and I can break it down. Similarly, if I have the probability of, let's say I ask you what is the probability of getting a blue and a green when you pick two balls one by one without replacement. What would I get? I would say probability of a blue again would be 2 by 9. But then I've kept that blue with me. Remember, probability of getting a blue is 2 by 9. 2 favorable, 9 total. Remember, you always respect the definition of probability. But what is your understanding of the 2 by 9? I'm picking, that's the probability of picking one blue ball. So I have picked one blue ball. The probability of that is 2 by 9. I'm holding on to it. So obviously now if I want a green, I have 8 total outcomes for the second and I want a green. So there are 3 favorable outcomes into the arrangement, 2 factorial. Now if you all ask me, but Aditya, won't GB be different answer? No, it will be the same answer. It will just be that the denominators are shifted. That's all. So the 2 factorial is absolutely fine. It takes care of it. So again, the order is not specified. So anytime the order is not specified, I have to consider the arrangements. And finally, if I ask you what is the probability of getting two blues and a green when you pick the balls one by one without replacement. Again, let's do without replacement. Again, I want you to use this visual representation. So probability of getting the first blue, 2 by 9. You're holding on to the first blue. So one blue is used into, I'm picking another blue. There are 8 balls left in the bag. There's only one favorable outcome. I'm picking the other blue into the green. The favorable outcomes are 7. That's the total outcomes are 7. The favorable outcomes are 3 into 3 factorial by 2 factorial. This is how you would break it down. Got it? Yes? Any doubts? Guys, any doubts on this? Thank you for the tip on increasing the size of the eraser. I've used it. Okay. Won't the denominator change, guys? I explained this, right? Probability of BG 1/1 without replacement, right? I said it is 2/9 into 3/8 into 2 factorial. Now you'll say, wouldn't the answer change? No, it will be the same. It's absolutely fine for me to write 2 factorial, because if I take, let's say, GB, it will still be the same, right? It will be 3/9 into 2/8. Right? You think 3/9 into 2/8 and 2/9 into 3/8 is giving you two different values? That's why I'm taking the factorial into consideration. The factorial takes care of the possibilities of GB. I don't have to list it out separately. Okay, that's the thing. The 2 factorial takes care. Why? What is this 2 factorial? Is the arrangement of these alphabets. So it's taking care of both the scenarios. Blue on the first, green on the second, or green on the first and blue on the second. That is why we are writing down the factorial. Understood? Perfect. Okay, so let's work with the next question. For the same bag of 9 balls, 2 blue, 3 green, 4 yellow, my question to you is, what is the probability of getting at least one blue when you pick 2 balls at random? I want you all to try it, please. I'll give you all a minute. I want you to try it. Right? Remember what I said. Comprehend the question, visualize, set up your visual component at the side, list out the logical cases. I'm going to use this question to add a couple of more pointers on the guidelines that I've written at the side for you to get a better understanding of this topic. Right? When I say at random means simultaneous. Simultaneous 1/1 without replacement. All right, that's what I meant. Right? When I say when you pick 2 balls at random, and I don't mention how it is done, that means you're putting your hand inside the bag, you're picking 2 balls simultaneously. Simultaneous selections have to be treated as 1/1 without replacement. 11/54. Okay. Don't make mistakes in terms of calculations. Okay. Remember, guys, always focus on two things. Set up your logic first. Set up your logical cases first. If your logic is sound, your math will absolutely be fine. If your logic is not sound, then the math is going to go awry. For those of you who are getting 11/12 and so on, remember, you're forgetting the factorials. More often than not, that's the mistake you'll make. Or you've not set up the logic right. Or you made some mathematical mistake, right? Mathematical mistake, I don't expect too many to make, but it's the logical bit which is the most important here. It's a very important point. And this will carry forward also, right, to probability permutations and combinations as well. Tushit, anytime I don't specify the arrangement, I have to take it, right? When will I not take the arrangement? Only when they tell me you need a blue followed by a green. I didn't say that. I just said at least one blue. So it can be blue green, blue yellow, blue blue, right? So I have to worry about the arrangements as well, right? Look at it from a common sense standpoint. Am I specifying what order? Am I saying it has to be a blue followed by a green? No. Okay, let's work with this. I have two blue, I have three green, four yellow, nine balls in the bag. Probability of getting at least one blue when you pick two balls at random. Now, there are two ways you can work with this. It's what I call forward logic and reverse logic. Let's go forward logic first. I want to first list out what are my logical cases. What are my logical cases? I need at least one blue. So at least one blue means minimum one blue. So I'll say I need a blue and I need some other color. It can be green or yellow. I'm being smart with my alphabets. You see, I'm not writing B, G, B, Y. I'm saying I need one blue. The other one can be any other color out of green and white. So I'm calling it others. I'm calling this group as other than blue. Or I have two blues. This would be what I call forward logic, where you're working with the question. You can absolutely write BY, BG, BB also and solve for those three. You'll get the same answer. But I'm being smart with my alphabets. I need one blue, the other can be anything I want. Or I need two blues. So I'm being smart with the alphabets. I'm grouping the greens and the yellows as one other and working with it. Now, let me break it down. What is the probability of getting a blue? Visualize, use your visual component, 2 out of 9. Remember, it's at random, so it has to be one by one without a replacement. So you've picked one blue. Use this visual component. The reason why most of you all are not getting the answer is because you all have not set up the logical cases and you're not visualizing the math using the visual component. I want you to use this. It gives you a very good sense of what the numbers are going to be. So 2 by 9, I've picked one blue. Other means it can be greens or yellows. So I have 8 total outcomes. And my favorable outcome can be either the greens or the yellows. So 1, 2, 3, 4, 5, 6, 7 into 7 by 8 into 2 factorial, the arrangement of those alphabets. Right? And the second, blue, would be 2 by 9. So I've picked one blue now. I'm holding on to that blue. I have 8 balls remaining in the bag. There's only one blue left into 1 by 8 into 2 factorial by 2 factorial, which will cancel out to give you 1. And see how smartly am I calculating, right? I'm not simplifying. I'm trying to keep the denominators the same. 2 sevens are 14s. 14 into 2 is 28 by 9 into 8 plus or is a plus 2 divided by 9 into 8. So 28 plus 2 gives me 30 divided by 9 into 8. 3 threes are, 3 tens are, 2 fives are, 2 fours are. That gives me 5 by 12. That is my answer. This is one way to work with it, right? So what are the mistakes you all made? I want you to evaluate. Did I use the visual component? Did I visualize the math well of how to put the numerator and the denominator? What mistake did I make? Did I forget the factorials? Did I do some calculation errors? So you need to work on that. This is one way to work. This is what I call forward logic. What I want you to notice is one thing. When I was listing out my logical cases, I was smart with the alphabets that I used. When I saw blue and the other can be green or Y, I just call them others. So so the number of cases, instead of 2 can become one case, and I can solve for it directly. Make sense? But the better way to work with such questions, whenever you have an at least one scenario, or a not scenario, or an at most one scenario, it's better for you to go reverse logic. So I'm going to put the fourth point here. While you're listing out your logical cases, put a filter in your mind. Ask yourself, how do I reduce the number of cases by being smart with the alphabets? Right? I'll just, instead of a point, I'll put it as a sub point. Group quantities smartly. Group quantities wherever possible to reduce the number of cases. So what did I do? I called the green and the yellow as not blue, and I worked. Jaiwal, I told you, right? At random means simultaneous. You're picking two balls at random. Simultaneous selections are exactly the same as one by one without replacement. That is why I subtracted the denominators, right? So group quantities wherever possible to reduce the number of cases. And second, always ask yourself, before you write down your logical cases, ask yourself, is it better for me to go forward logic, or is it better for me to go reverse logic? Forward logic is to work directly for what the question is asking you. Reverse logic is to take the total and subtract what you don't need. And always ask yourself, which would be better? Always pick the logical case that gives you lesser number of possibilities. I would always go the reverse logic process when I'm dealing with words like at least one, at most one, not, when I have a negative connotation like not. Reverse logic is always recommended. Why? Because by default, it will give you the least number of cases. Right? Now, if I'm going reverse logic, what is reverse logic here? There are two blues, so it can be 0 blue, 1 blue, 2 blue. They are asking me for at least one. At least one means 1 blue or 2 blue. So what is the case that I don't need? The case that I don't need is when there are 0 blues, when there are no blue balls. So that is what you do in reverse logic. You take the total and you subtract the case that you don't need. So what is my total probability? What is the total probability in any probability question? Remember, probability is always going to be between 0 and 1. So the maximum probability will be 1. And I'm going to subtract the cases where there is no blue ball. So the total is 1. So probability of no blue. So probability of no blue means probability of other than blue, other than blue. I'm not going to sit and write green, green, yellow, yellow, and green, yellow, and solve the three. I'm being smart with my alphabets. Probability of no blue means I need the others. Right? I'm not going to do 1 minus yy, gg, yg. What is yy, gg, yg for me? Oh. Right? So what is the probability of getting an other than blue? 7 by 9. Into, I've picked one of the greens and yellows into, look at this please, 7 by 9. Why did I write 7 by 9? Because I need other than blue. So 1, 2, 3, 4, 5, 6, 7. 7 favorable outcomes divided by 9 total outcomes into, I've picked one of the green and the yellows. So I have 6 out of 8 into 2 factorial by 2 factorial, which will cancel out. Now I'll simplify. 3 2s are 3 3s are 2 1s are 2 4. So that gives me 7 by 12. So 1 minus 7 by 12 would give me 5 by 12. That would be the fastest way to work with this question. Got it? Don't forget to do the 1 minus. So remember, write down the logical case. When you're working with logic, I've written the 3 things here. Try to be smart with the alphabets. It'll help you list out the number of cases. Keep the number of cases smaller. Ask yourself, should I go forward logic or reverse logic? choose the logical case which give you lesser possibilities, and always by default use reverse logic when you have an at least one and at most one and not. And once that is done, simply use the probability of a complex event formula to break things down step by step by step. This is what you have to do in any complex event question. Anything they give you, whether it's people, balls in a bag, cards in a deck, this is the structure that you have to make use of. Got it? Any doubts in the forward versus reverse logic, guys? Clear? Okay. If we club the others, the arrangement would be accounted for separate cases. When I'm clubbing the others, I'm using alphabets smartly, no? O, O. So I'm calling them blue, and this is the other than blue, right? So what I put as my alphabets is what I would use as my arrangements. If you write it as GY, then you'll have to take the arrangements. If you write O as GY, for these two, you don't have to take because the alphabets are the same. For this, you have to take. If you take the arrangements and add them up and subtract from one, you'll get the same. I'm being smart with my alphabets. What I write as my alphabets is what I would take as my arrangements. Got it? I'm being smart with it. That's how you can reduce the number of cases. I'm making it, like I said, right? I'm making it more and more complex. This is the highest complexity you can go to. I'm saying what is the most efficient way to work, right? I would want to group quantities wherever possible so that I can reduce the number of cases, but it's absolutely okay for you to write all of this down as well. Okay, if you don't, visualize that you can take that as another alphabet, it's fine to list it out, fine. But forward versus reverse logic, I would definitely recommend for you to work with, because you'll have to identify where to use reverse logic, right? Okay, so I'm going to keep those guidelines on the side there on the screen. I'm not going to change that, but let's look at some questions. Okay, go back to this. Let's do, yes. Let's try question 9. Give it a shot. At most one blue, YY reverse. What will be at most? Maximum one, no? So it will be 0 and 1, right? So what is the case that I don't need? Both are blues, correct? That's why you have to bring in logic, okay? At most one means 1 and 0. I have to solve for 0 blue, 1 blue. What is the case that I don't need? 2 blue. So I'll calculate 2 blue, subtract from my total. For all of you who are working, guys, pause. I want you to follow the structures. Read, visualize, comprehend, set up your visual component at the side. 8 volunteers called Andrew A, Karen K. Mark the others as O1, O2, O3, O4, O5, O6. Put that stickman figure. I want you to use that visual representation. Don't get into the habit of just forcing yourself to do the math. Then read the question, understand the meaning of it, set up the logical scenario, then break it down using the formula. That should be the process. Tushit, can you have 12 by 7 as an answer? I think you must have put the 1 by mistake, I'm assuming. Can't have the probability to be more than 1, no? Guys, hold off from typing your answers until I ask you. Some of you all might go back to your old process and use combinations as well. So if you do that, then I have a follow-up question for you after. Okay. So that question I'm going to ask you is, why didn't you use combinations in the next question? Okay. Be smart with the alphabets. Anything that deals with logic and common sense is always messy. Right? So you need to focus on figuring out the question, the logic, visualize, and then work. What I've given you is a structure towards how to work. What you need to focus on is the setup of the logic and the reading and the comprehending. Okay? And that's the most difficult bit. Okay, you can start putting your answers in the chat window. Okay, somebody said 6C3 by 8C4. Okay. So Pratik, I want you to, for the next question, tell me how would you represent that with combinations, okay? You can, but let's see how you do it. Guys, for those of you all wondering, why am I not using combinations? I've learned probability as combinations. I told you, I'm not using a combination process of working. I'm using a permutation process of working that works across all questions, whether it's tossing coins, rolling die, picking people from a group, balls from a bag. This process will work everywhere. It's just about understanding the question and breaking it down and setting things up. No problem, Pratik. You can actually go back and look at what I've done in the beginning, right? But good attempt anyway on that question, even though you use combinations. It's the right answer. All right, so let's discuss. What I want you all to do is observe how I'm setting things up, how I'm setting up my alphabets, how I'm setting up my logical case and working. From a group of 8 volunteers, including Andrew and Karen. So Andrew, Karen, and I have 6 other people. So I've set up my visual component at the side, put the stickman figure there. I'm standing in a room. I have these 8 people in front of me. 4 people are to be selected at random to organize a charity event. Now, like I said, if you're selecting people, nobody's going to tell you with replacement or without replacement. If you're picking one person, means you're not going to put him back to be a part of your team, right? It's obvious without replacement. What is the probability that Andrew will be among the volunteers selected and Karen will not? So I want you all to visualize, put yourself in that room and ask yourself this question. I have Andrew, Karen, and 6 others in front of me. Someone from outside comes and asks me, I want you to select 4 people such that Andrew is always a part of your team, but Karen is not. What will I do? I will definitely pick Andrew first. But then I'm not going to pick Karen. I will pick 3 of the others. So I'm going to group them. I'm not going to write O1, O2, O3, O2, O3, O4. That's too many cases for me to work. So I'll just say I'm going to call the others as one entity, right? And I'm going to say Andrew and 3 others is what I need. It could be any of the 3 others. I will cater to any of the 3 others in my fraction when I'm writing the probability, right? I need Andrew. That's what I would do, right? If anyone came and asked me, Aditya, you have these 8 people in front of you. You need to pick 4 people, such that Andrew is always a part of your team, but Karen is not. So I will pick Andrew first, and randomly I will go to the others, ignore Karen, and I'll pick 3 of them and make them a part of my team. I'm representing my logic exactly the same way, right? So A, O, O, O. And there's no order that is specified here, so I have to cater to the arrangements as well. Now, and this is the only logical scenario I'm going to work with. Now I would break it down. What is the probability of picking Andrew? 1 out of 8. I'm looking at my logical component, visual component, and I'm working 1 out of 8. So I've picked Andrew now. I need an other. I need someone who's not Karen. So I have 7 people left, but I can pick any one of these 6. So 6 out of 7. My favorable outcomes are 6. My total outcomes are 7. Some of you all would have directly put 1 by 7. That's a mistake. Then you're violating the definition of probability. You see, when I'm writing my fractions every time, I'm respecting the definition. It's favorable by total. Favorable by total. I've picked one other. Now I need another other. So it's going to be 5 by 6. One more I pick. You see how I'm using my visual representation? Into 5, 4 by 5. Into the arrangement of AOO, which will be 4 factorial by 3 factorial, which is 4. So now I can cancel out the 5. I can cancel out the 6. 4 ones are 4 twos are, right? 4 factorial by 3 factorial is going to give me 4. 2 ones are 2 twos are. That will give me 2 by 7. That is my answer. I solved it using common sense and visualization. My logical setup was exactly the way I would make a selection in a real life scenario. I would pick Andrew and I would pick 3 others. When I wrote, I was smart with my alphabets. Why? Because I know that I can cater to any of the others in my probability when I write down the fraction. So I just said A, other, other, other. Got it? Any doubts in this? You see, question like this becomes much simpler to work. Somebody did with the combination. Yes, you can use it with the combination. But the next question, if you use combinations, it's going to be a big, big issue. Okay. Why 4 factorial by 3 factorial? Because Andrew need not be selected only first. No, I can select an other first, then I can select Andrew, then another, and then another. Right. I don't need to. I can do O A O O also, or I can do O O A O or O O O A. Right. So the 4 factorial by 3 factorial takes care of these 4 cases that you have. So you don't need to list out the other 3. Got it? The arrangements are not specified here, so I have to take the arrangements into consideration. Okay. Okay, great. Let's move to the next question. Another official GMAT one, a hard one, classified as a 700 level. Okay. Again, like I said, imagine you are Tanya. You are doing whatever is being asked in the question. Visualize it from a first person's perspective. Write down your logic and then break it down using the math. Okay. Give it a shot. For the question, you all can become Tanya, right? Visualize it from her perspective. Tushit, why 3 factorial? Because the 3 O's, right? A, O, O, O. You count the alphabets individually, write down that factorial, divide by the repeating letter factorial. So the 3 O's I divide by 3 factorial, right? It's the alphabet arrangement. Sorry, I didn't see your question. I'm answering it now. I'm grouping the others as one group, Tushit. So in my probability, I take care of that. If you do that, if you consider them individually, you have to list out all the different 3 combinations that you have to take out of the 6. That will be very difficult, right? Good job, Pratik. You can start putting your answers in the chat window. Good job. I see most of you are giving me the right answer. Can't visualize. Okay. You have to set up your visual component. Yes, that's a good start. Yeah, well, L1, L2, L3, L4, E1, E2, E3, E4. Right? Now ask yourself, if you were Tanya and you need to put exactly one letter into the correct envelope, how would you go about doing it? Take a reference point, right? And then break it down like that. Okay, let's discuss. Tanya prepared 4 different letters to be sent to 4 different addresses. So I'm Tanya. I prepare 4 different letters. Let me call it L1, L2, L3, L4, since most of you would have used that. And let's call it E1, E2, E3, E4, or A1, A2, A3, A4, whatever you want, right? The envelopes here, right? For each letter, she prepared an envelope with its correct address. So L1, E1 is the correct address, L2, E2, L3, E3, L4, E4. If the 4 letters are to be put into 4 envelopes at random, what is the probability that only one letter will be put into the envelope with its correct address? So I want to put the letters into envelopes, but the condition given to me is I need only one letter to be put into an envelope with its correct address. And if I need one letter only to be put into its correct address, then the other 3 letters have to go into the wrong envelopes. So I'm going to set it up as P, correct, wrong, 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 right? P, correct, wrong, wrong, wrong. I know that correct can be anyone. It can be the first one or the second one or the third one or the fourth one. The factorial will take care of that for me. But I know I need to have one correct and the other 3 wrong. I'm setting up that logical case. And I'm going to work it out, let's say by taking C to be the first letter to go into the correct envelope and the other 3 going into the wrong, and the arrangement will take care of that for me if I want to do the second or the third or the fourth. So what will I do? I want the first one to go into its correct envelope. So L1 goes to E1. So what is the probability for that? L1 has 1, 2, 3, 4 total outcomes. Out of that, the favorable outcome is only 1. So it will be 1 by 4. So let's say now L1 has gone to E1. You see, I'm visualizing it. L1 has gone to E1. L1 is done. E1 is done. Now L2 has to go to the wrong envelope. So L2 has 1, 2, 3 possibilities, 3 total outcomes. But if it has to go into the wrong envelope, it can't go to E2. It can go to E3 or E4. So there are 2 favorable outcomes. So let's say L2 goes to E3. I'm just keeping like a placeholder so that I can visualize it better. You can put L2 to E4 also, no problem, right? Now I go to L3. L3 again has 2 possibilities, E2 and E4. But L2 cannot go to E2 because L3 cannot go to E2. Because if L3 goes to E2, then L4 will go to E4. That will make another correct. I can't have that. So L3 has to go to E4. So it has only one favorable outcome. L3 to E4. And finally, L4 has to go to E2. That is 1 into the arrangement. 4 factorial by 3 factorial, which is 4. Why? Because I don't need only L1. I don't need the case only where L1 goes to E1. No, L2 also can go to E2. L3 can also go to E3. L4 can go to E4. So 4 factorial by 3 factorial takes care of those possibilities for me. Now I'll simplify. This goes, the 4 goes here with 4. That gives me 1 by 3. That's my answer. For those of you all who got accustomed to using combinations, it'll be very difficult for you to work this question with a combination. So you see, I'm integrating that same process of what we did with tossing coins, picking balls from a bag, even with questions where objects are being picked, people are being picked, letters are being put in envelopes. Anytime you work with more than one object, it's a complex event. Anytime it's a complex event, follow the probability of a complex event process to work. Got it? So that's the core probability aspect. I'm not going to, I don't think we'll have time to pick the other questions that we have, but I'll do the OR probability for sure. So at the end of the session, maybe tomorrow, I will write down explanations for the other questions also that I have in this PPT, and I will send you that PPT so you can, work those questions and look up the explanations as well. So this is what you do for a complex event. Okay. So last phase, this is going to be very truthful, the record time that I've taken a session. I think the last session was around 3.5, so it may go to 4 hours. I just need another 20-25 minutes, guys. So if you're okay to pull in for another 30 minutes, let's finish off the OR probability. OR probability is more visual in nature. So we'll look at what that is. We'll look at a couple of examples, and then we'll wrap up. Up for it? Yes, I think there's already 50, 51. Thank you for staying, for so long. I know it's a long day. I hope tomorrow's a holiday as well, but let's look at it. All right. I'm shifting again to my sketchbook. Let's look at the OR probability. Now, like I said, whenever you see a question and when the question asks you what is the probability of A or B, probability of either A or B, neither A nor B, instead of going with it mathematically, the better way to work with it is to go with it visually using Venn diagrams. But you need to have a good stronghold on the Venn diagram topic if you're going with this. Okay. I did get, a Venn diagram based two-part analysis question, which is a probability related one, on a test. So I know this is a very, very important concept as well. Okay. So in an OR probability, what you need to do is you need to represent the probabilities as circles. As circles. And you need to ask yourself one important question. Do the probabilities, can the events, let me put it that way, can the events overlap? Is it possible? Basically, can they occur simultaneously? Can the events overlap? Can they occur? Can the two probabilities occur simultaneously? If the answer to that is a yes, it is they can both occur simultaneously, then it is what we call in a mathematical sense mutually inclusive set of quantities. And you would represent the probabilities in the form of an intersecting when, like this. But if the answer to that is a no, then you would have studied in previous mutually exclusive, mutually inclusive. I'm trying to avoid jargon, but I'll use it here. Mutually exclusive means there will be non-intersecting wins. Mutually exclusive, very easy to solve. So I don't think you'll get it, but simple as this, right? You represent the probabilities in the form of circles, right? And you ask yourself, can these occur simultaneously? Can they overlap? If the answer to that is yes, intersecting circles. If the answer to that is no, non-intersecting circles. Give you an example. Simple. Let's take mutually exclusive first. Okay. I'm a football fan. So I'm going to use a football example. Let's say the probability of Manchester United winning a match is 0.7. And the probability of Arsenal winning the same match is 0.2. Now think about it. If Manchester United and Arsenal are playing the same match, yes, they're playing against Arsenal. If Manchester United and Arsenal are playing the same match, is it possible for both of them to win? No. So I'm representing the circles because the circles are the probability of Manchester United winning, the probability of Arsenal winning. You can't have both of them to win simultaneously. There can be a draw. I've catered to that as well because I've not given the totals to add up to 1 at this point. So 0.1 is the probability of a draw. But I'm representing the probabilities as two non-intersecting circles. Right? So you know where my support lies. Okay. So if I want to find out the probability of Manchester United or Arsenal to win the match, it's very simple. It's just taking the two circles and adding them up. Right? So 0.7 probability of Manchester United winning or Arsenal winning would be the probability of Manchester United winning plus the probability of Arsenal winning. That will be 0.7 plus 0.2. That will be a 0.9. And the remaining 0.1 is the event of a draw. An example of a mutually inclusive set of quantities would be something like this. The probability that I win a lottery is 0.4. And the probability that I get struck by lightning is also 0.4. Now think about it. It's a very, improbable situation, but I can win a lottery and get struck by lightning. It's possible for both of them to happen simultaneously. So I'm going to represent them as two intersecting circles. So the probability of getting struck by lightning is 0.4. Now, when you have a mutually inclusive set of quantities, the variations that they will bring in with questions is going to be a lot more. Because you have intersecting circles, it's like a pure Venn. You have to be careful with what regions they are asking you to solve for, right? So the first question can be, what is the probability of winning a lottery or getting struck by lightning, right? I'm working with logic, right? I mean, I'm working it with simple understanding, right? If someone tells me probability of A attending a class, probability of B attending a class, logic is both A and B can attend the same class, correct? Probability of India winning the match, Pakistan winning the same match is not going to be possible, right? So it's non-intersecting circles. Okay, so you're saying about winning a lottery, getting struck by lightning. I'm just using a simple example. Okay, try to keep the fun quotient bit. But if you want to, I'll take another example, a boring example later with cards and so on. But I just want you to understand this. The point I'm trying to make, the overall point I'm trying to make is that when you're working with probabilities, the question you need to ask yourself is, do these events overlap? Can they occur simultaneously? Right, however improbable it might be, however however say outlandish it might be, it's possible for me to win a lottery or get struck by lightning. So I'm going to say intersecting circles. So if I want the probability of winning a lottery or getting struck by lightning, I will draw the small Venn at the side. The first thing I have to do, I have to understand my question, and I'm going to shade the quantity or shade the portions of the Venn that the question is asking me to solve. So they want this entire portion. So this is like a 0.4. This is also 0.4. So they want the entire shaded portion here. So how will I get that shaded portion? If I take the entire first circle, the probability of winning a lottery, I take the entire first circle, add it to the entire second circle, the probability of getting struck by lightning. But by adding the two circles, I've considered the overlap twice. I've double counted it. So I need to remove that extra count. And what does the overlap represent? The probability of winning a lottery. I'll write it down here. Minus the probability of winning a lottery and getting struck by lightning. I need to remove one time the overlap. Now I can work with it. 0.4 plus 0.4 minus 0.4 into 0.4. That will be 0.8 minus 0.16. That will be 0.64. That will be my answer. So you see, I just didn't draw the Venn and work with it. I shaded the portion that the question asked me to solve for. And then I went into how do I get to the shaded portion. So I took the entire first circle, added it to the second circle. But by adding the two circles, I have considered the intersection twice. I've double counted it, so I removed the intersection. What was the intersection representing here for me? The probability of winning a lottery and getting struck by lightning. Got it? Another variation of a question they could have told you is, what is the probability of either winning a lottery or getting struck by lightning? So again, I will draw the circles. What is the meaning of either W or L? Either means I need one of them to occur. I can't have both of them to occur simultaneously. So they want this portion and they want this portion of the Venn. So what will I do? I will take the entire first circle, probability of winning a lottery, add it to the entire second circle, the probability of getting struck by lightning, minus, I don't want the intersection at all, 2 times the probability of winning a lottery and getting struck by lightning. Why is it 0.4? Because there's an and possibility. Why? Right? What is the probability of W and L? And means P of W and L means P of W into P of L. And always means a multiplication. Got it? So 2 times, I'm adding the two circles, but by adding the two circles, I've included the intersection twice. So I don't need the intersection at all. I'm removing twice the intersection. And the intersection again represents W and L. So 0.4 plus 0.4 minus 2 times 0.4 into 0.4. That will be 0.8 minus 2 into 0.16, 0.8 minus 0.32. That will be 0.48. I can also give you what is the probability of neither, somebody asked, winning a lottery nor getting struck by lightning. So again, neither and nor means what is outside. So easy way to work, go reverse. Whenever you have negative connotations like this, go reverse. So 1 minus probability of what is inside. I've already solved what is inside. That is probability of W or L. Right? What is inside is W or L. So 1 minus 0.64. That is 0.36. Right? So when you have mutually inclusive set of quantities, there will be different variations of questions that they can ask you. Any sort of variation. I just use 3 variations. Your job is to understand the question and shade the portions of the when that they are asking you to solve for. Mutually inclusive exam, sir, logically the answer should be lesser than individual. Uh, my answer is lesser, no? The total probability is 1, no? You're saying, no, this is 0, the intersection is 0.16, right? So that is lesser. I didn't understand your question, Vivek. So can you rephrase it better? The others, have you understood what needs to be done in an OR probability scenario, right? This is how you'll have to work. You'll have to represent the probabilities as a when, understand what the question is asking, and shade the portions of the when. More real life example would be, what is the probability of getting a king or a queen when you pick one card from the deck of cards? So I see the word or, I'll say, okay, I'm going to represent them as circles. But can a king be a queen? Definitely not. So I will draw two non-intersecting circles. This would be the probability of a king. This would be the probability of a queen. I can't have them both. So the probability of a king, for those who know how cards are, it's 52 cards and there are 4 kings. So 4 by 52 plus 4 by 52. Is there a condition we will add? No, Pratik, I will not add, right? Because that's why I said, right, you should have a very good stronghold of Venn diagrams. It's like areas, right? I'm taking the area of this entire first circle, I'm shading it for you. And then I'm taking the area of the entire second circle, I'm shading it for you. You see, this middle section has lines from the first and the second. So I've counted it twice now. So if I want the area of the entire shaded region, it's the area of the first circle plus the area of the second circle minus, since I've taken the intersection twice, minus 1 time the intersection, right? I'm just looking at it visually there, okay? You'll need to, if you're not able to do that, then I think you need to go and look at how to work with bends. But it depends on what they ask me to shade. Got it? P of W plus L is less than P of W or L. I mean, the occurrence of an event is of getting struck by lightning, winning a lottery should be less. No, that depends upon. Uh, no, it's two separate things, right? Okay, why? It's not 4 by. It's not king and queen, right? It's king or queen. No, it's you're picking. Okay, let me give you the question here. What is the probability of getting a king or a queen when you pick one card from the deck of cards? When I'm picking A or B, why? I'm only picking one. Got it? When I get A or B, right? I'm picking only one out of them. So one card from the deck of cards. So if I'm picking one card, P of K would be 4 by 52. P of Q would be 4 by 52. That will be 8 by 52. Can simplify that to the lowest form. But if I ask you what is the probability of getting a king or a heart? Now you have to understand that I can also have, when you pick one card from the deck of cards. King, what is the probability of getting a king or a heart? Now think about it. I can also have a king which is also a heart, right? So I represent it with two intersecting circles and I want this entire shaded portion. This is the probability of a king. This is the probability of a heart. So the probability of a king, probability of a heart, that's 4 by 52 plus 13 by 52. I'm taking the entire first circle I'm adding it to the entire second circle. I'm considering the deck has 52 cards, guys. Okay, 13 by 52 minus the intersection, since I've considered the probability of a king and a heart. That will be 1 by 52, if you know how cards are. Okay, so 17 minus 1 is 16 by 52, that I can again reduce to its lowest form. So a more, say, real life example with cards would be something like this. The point I'm making simple is when you have an or scenario, represent them with wins. The question you need to ask yourself to figure out if it's intersecting or non-intersecting is, can they both occur simultaneously? If they occur simultaneously, draw the intersecting wins. If they don't, put two separate wins. Look at the question, shade the portion, solve. Simple. Okay. Okay. So let's. No, Maxmin I won't cover because that's a core. It's a core Venn diagram bit. So I've done a bit of Maxmin in one of the quiz videos where I discussed Venn diagrams. I explained about Maxmin and I put some guidelines. You'll be helped with that, Jaiwal. Okay. Maxmin is more of a Venn diagram statistical concept that is there with probability because we are dealing with Venns, but I'm not going to do it here. Okay. So let's take an example. Okay. Let's try question 5. Give it a shot. Min max probability will be with Venn diagrams mostly. Okay, so look up the Venn diagrams bit. I think it's one of the quizzes. Start with an easy one here. Should not take you too much of time to solve. Okay? You can start putting in your answers in the chat window. There's two ways to work with this question, guys. You want to list it out also and count it out. That is also totally fine. You want to draw at the Venn and say there's an overlap. That's also totally fine, right? 2 is the one that will always be out, right? Okay. So if an integer is selected at random from the set of integers from 1 through 20, what is the probability that the selected integer is prime or odd? So I have the total outcomes given to me already as 20. for people who want to go with a fundamental definition, you can list it out. The favorable outcomes, I need prime or odd. So you can list it out as one way of working is, say, I can put 2, 3, then 5, then 7, 9, 11, 13, 15, 17, 19. And you can list it out like this and then count it out. These would be my favorable outcomes. So small numbers like this, right? Quickly, you can easily count it and finish it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think 2, 3, 5, 7, 9, 11, 13, 15, 17, 19. So how many? Have I missed any? One also, right? So that gives me a total of 11. So 11 by 20. That would be my answer, right? The other way to look at it, say prime or odd, right? This is prime, this is odd, right? You can have a number that is prime and odd as well. So the numbers that are prime and odd would be what? 3, 5, 7, 11, and so on, right? So I can take the probability and I want this entire thing, right? So it's easier for you to list it out, or you can use the when as well. So the intersection, you need the probability of a prime. There's only one. Um, there's only one even prime, so I can say the prime numbers would be this two would be here. All the other odd numbers would be in the intersection. So I can find out that the probability and keep adding them and working this, right? So 2 is the only even prime. All the other prime numbers are odd. So the overlaps I would have would be 3, 5, is 7, 7, 11, 13, and 17 and 19, right? And you can work with it. But this question was easily solvable by listing things out. So you don't need to, work with the, even though it's an or possibility, listing out absolutely works, right? But in the next question, I'm sure you may have to think through a bit. Give it a shot, please. Here also, you can list things out, possible, because the values are smaller. You can also use the when. Do whichever you're comfortable with. Yes, with the flow, 9 doesn't is not in the intersection. It has to be only odd. So 3, so 2, 3, 5, 7, 11, 13, 17, 19. Right? Multiple ways of working this. Because you're picking one, you can boil it down to a single event, figure out the total outcomes, figure out the favorable outcomes, divide the two. Since you have an or, probability of medium or red, You can use the when as well if you want to visualize. Both of them are possible. Okay, so let's discuss. I'll show it to you both ways. Okay, I will draw the when as well here, but ideally you can list things out because the numbers are small. So again, let's read the question. A certain store sells small, medium, and large toy trucks in each of the colors red, blue, green, and yellow. So I have small, medium, and large. If I was working with it, with the baseline understanding of probability. And each of these sizes have four different colors: red, blue, green, yellow. This would also have red, blue, green, yellow, red, blue, green, yellow. The store has an equal number of trucks of each possible color size combinations, ratifying what I've drawn. If Paul wants a medium red truck and his mother will randomly select one of the trucks in the store, since you're selecting one, it would be a single event. I can list things out and work with it. What is the probability that the truck she selects will have at least one of the two features? So there are two ways you can work. I see the word at least one also. So I can go with it using forward, or I can reverse and work as well. We'll see both. So if I was going with the normal way of working, my total outcomes, my total possibilities would be 12. And I need my favorable outcomes to be, I want a medium or a red. Paul wants a medium red truck, and his mother will randomly select one of the trucks in the store. What is the probability that the truck she selects will have at least one of the two features? Right? So it can be red, or it can be medium, or it can be both. So basically, I have to count out the reds and the mediums. So the small red is a possibility. That's one. The medium red is a possibility. The medium blue, the medium green, the medium yellow, all the medium, four mediums are possibilities. And the large red is also a possibility. So that's 6. So 6 out of 12, which would be half. This is one way to work. The other way to work is to take the total. At least one means total minus no features. Right? You could also done that. But if you're going to go that route, then you should have written the probability of getting a small, medium, or large, right, is the probability of getting a medium here, since that's the question, is 2 out of 3 because there are 3 sizes. Probability of a medium would be, sorry, this is 1 out of 3. The probability of a medium would be 1 out of 3. And the probability of getting a red would be 1 out of 4. Right? This is what you would have written. Now I need total minus no features. That means the total probability is 1. So I need the probability of not getting a medium and the probability. I have to remove the case that I don't need. What is the case that I don't need? Not having a medium and not having a red. I'm going to remove that. So 1 minus probability of not getting a medium would be 2 by 3. Not getting a red would be 3 by 4. This is another way some of you all looked at it. 2 ones are 2 twos are. 1 minus half would give you half. That's also a possibility. Yeah, reverse is much better. I agree with you. Some of you all would have gone with the process of using whens. The probability of a medium again is 1 by 3. The probability of a red would be 1 by 4 is from what I got in the question. And they want the probability of getting a medium or a red, right? So I draw the when. This will be the probability of getting a medium. This will be the probability of getting a red. And I have only one truck that is both a medium and a red, right? So the probability of getting the medium would be 1 by 3. The red would be 1 by 4. So probability of I need this entire portion. That's what the question is asking me. So I'll calculate the probability of a medium plus the probability of a red. I need the entire shaded portion. I'm taking the first circle, adding it to the second circle, but I've considered the intersection twice. So I'm removing the probability of medium and red once. And means multiplication. So that's 1 by 3 plus 1 by 4 minus 1 by 3 into 1 by 4, right? So 1 by 3 plus 1 by 4 minus 1 by 12. Take that as 12. 4 plus 3 minus 1. 7 minus 1 is 6 by 12, which is 1 by 2. That's another way to work with it. Okay. Could you give a question where using a when is much simpler method than the other methods? Okay. Okay, let me see if I have one here. Before I go forward, right? Any doubts in this, guys? Any doubts in this? Tushit, the using the when is just a more recommended process because you're able to visualize it, right? If even if you're able to list it out and visualize, it's totally fine, right? But let's say, let me pick a question here if I have one here. I don't have a question, but I do have it in my repositories. It's too late for me to pick that out now from my repository. So what I'll do is I'll add that question for you, Tushit, specifically, where you're saying no, saying that it's not visual. Okay, I'll pick a question for you. I'll add it into this slide, and I will also write an explanation for that to you. Okay, you can go through that. It would be more in terms of data sufficiency question. So if I give you a data sufficiency question, right, and I ask you about regions of the when and in terms of probability, then using the when to visualize the regions would be much better. Something like if I give you a two set when, then I ask you what is the probability of either, what is the probability of either or. If I give you a three set when and I ask you what is the probability of finding, a person who's part of community A and community B, but not community C. So in that case, right, listing out all the possibilities by writing it down would be too problematic, right? So visualizing it as what areas you require would be better. It's a choice. It's not. That's why I said or probabilities is a choice. The reason why we represent it as a circle, you can just use formulae as well. You can say P of M or R. You can take it as a formula is P of M plus P of R if they are mutually inclusive minus P of M and R. You can remember this as a formula for mutually inclusive quantities as well, right? And use it mathematically. It's totally fine. I prefer to use it visually. And like someone also said before, there are maximization, minimization questions. Ideally, I would have picked that for a Venn diagram as well. Maximization, minimization question requires you to have a very good stronghold on Venns. The reason I couldn't pick that here is because it tests you on more on a understanding of a Venn diagram, and it was more about probability, right? So I just stuck to this. Got it? Yeah, Jaiwal, tell me. If you are okay to wait for maybe 5 minutes, I can maybe pull out a question from my repositories that deals with this. if you want it. Let me see if I can pick it up from the worksheet of mine. It's a good question you asked. So let me just give me 2 minutes, okay? And I should be able to pull up. Okay, I've picked up from my mobile, I've opened up a worksheet of mine. So I'm going to write the question if you don't mind here. Okay, Tushar? So let me do that. Okay, the question says if the probability is 0.7 that event X will occur. And this is for also Jaiwal because you asked me for a maximum, right? And 0.85 that event Y will occur. What is the least possible value of the probability that both events occur? Okay, here's your question, right? So I'll give you 5 minutes since you asked me the question. I will cater to it. Somebody said maximum, I'll cater to that as well. Okay, give it a shot. For those of you all who want to log out, guys, you can log out. This is an extra bit that I'm doing because it was a good question that Tushit asked, right? Where will probabilities with wins be better? And somebody asked for maximum as well, so I'm catering towards that, right? If the probability is zero point 0.7 that event X will occur, no, that's not 0.7, Tushit. That's not the right answer. Yeah, Jaiwal. 0.595 is one of the answer choices. I didn't give you that. 0.7 is also one of the answer choices, but both of them are not the answer. So this is an example, Tushit, where Venn diagrams will help. So you'll have to visualize it as a Venn. So the first thing is I can have both the events to occur simultaneously, right? And the question was also asking me, Tushit, it was not asking me what is the possibility. Ask me the least possible value. That is also one. So it's testing you on something called a maximization minimization concept of a when. So what I mean, I want you to go through that question, that statistics question quiz that I did. I explained about maximum. I'll quickly do it, right? um, so this is what you would do. Okay, this is X, this is Y. So probability that event X will occur is 0.7. The probability that event Y will occur is 0.85, and they're asking the least possible value that both events can occur. So this is the intersection. Plus, I have to understand that there is something outside as well. They have not told me everything is inside the circle. That's the first big assumption that people make in a Venn diagram. It will be very difficult for me to just solve it using mathematical. Using mathematics. Yes, 0.55 is correct, Tushu. So now I would say this is X. Whenever I'm working with a maximum, this is for you, Jaiwal. Whenever I'm working with a maximum question, it's better for you to always finish the Venn diagram like this and then create an equation using your total, right? Plus X plus 0.85 minus X plus Y should be equal to 1. Remember, probabilities always add up to 1. So this goes, that will give me 1.55 minus X plus Y is equal to 1. And since I need to maximize or minimize X, I will isolate that. So X is equal to, I'll take the X to the right, 1 to the left, is Y plus 0.55. This is what I would do. For a maximum question, always finish the when, make an equation using the total and isolate the quantity that you want to maximize or minimize, right? Now, once I isolated the quantity I wanted to maximize or minimize, the question asked me what is the least possible value of X. So the least possible value of X will depend upon Y. That means Y has to be the least, and the minimum I can go to for Y is 0. So x would be 0.55. That is my answer, and that is the correct answer as well. It's neither. Jaiwal, why is neither? I cannot assume. Nowhere in the question are they telling me that neither of the events cannot can that outer region is zero basically, right? Yeah, Tushit, you can use the complement as well. Complement actually would be better. That was a good catch, Tushit. You could have said this is 0.3, then you could have said that is 0.15, and then you could have taken the intersection. That is also totally okay. You can use the complement formula as well, right? You can also do that. Absolutely okay. Got it. So this is an example, Tushit, of why a Venn diagram would help. So where does a Venn diagram help? It would help you in Max-Min question. So normally probability they'll attach it to when in a Max-Min. They will attach it to a when in a three-set when. So that is where the visualization of the when would make more sense. Got it? Great. Fantastic. All right, guys. So that's it. This is what I hope I've changed your outlook on probability. I've put in a structure. See, what I've done is I've put in a structure of how you're going to approach probability questions in the most simplistic way. But like I said, the biggest difficulty or the biggest things that you'll have to, the focus areas for you should be on the reading, the processing, and the visualization of the question and how you set up your logic. If you're able to figure these four out, the structures will help you put in the math really well. Okay. So that's what I had, right? I hope the session is useful for those of you all who came in halfway. Guys, look at the session from the start. It will make a lot more sense to you. I hope this video is out there for everyone to look at and not get afraid of probability anymore, right? So we have other sessions coming forward as well. We'll tell you the dates as we go forward. Stay subscribed, like the video, and wait for the notifications for the other topics. All right. So we are going to discuss about absolute values. We look at permutations and combinations going forward. We look at time and work as well in one of the sessions, and we look at some bit of remainders as well. Okay, that's what we have coming up. I think you'll get notifications for it. I hope to see you in the other sessions as well. Thank you for staying up for so long. It means a lot. And I hope you have a good weekend. And for the Arsenal fans there, I hope your weekend doesn't go too well on Sunday. Thank you. Bye.